A very good morning to all. I welcome you all on the InDACON 2022 International Conference on Desalination and the Water Treatment, Recent Technology. This is our day 2 of the sessions, in which in the day 2 online sessions, we have 3 keynote speakers. First one, Professor Tamal Banerjee from IIT Guwahati. Second, Professor S. Shaktivil from TCL Mumbai. And the third one is Professor Shankar Karale from Aarti Industries Vadodara, Gujarat. We have in the sessions as a keynote speaker session chair, Dr. Anupama Sharma ji, Dean, Punjab University. In the other sessions we have from technical session that will start from 11 a.m. onwards. So we'll start with Professor Tamal Banerjee. I request you, Professor Tamal Banerjee, to start.
So you have to unmute yourself.
Yeah. Thank you, Professor Saraswat and the entire organizing team of InDACON 2022. So there will be some sound which will maybe coming because I'm very close to some, there was some railway station. So maybe you just have to, try my best to eliminate the background noise. So right now I'll just share.
Professor Tamal,
yes.
Please hold on.
Yes.
Just, sorry for interruptions. I just want to give you the brief introductions about you, then we'll start, please.
Okay.
All right. So Professor Tamal Banerjee is currently a professor at the Department of Chemical Engineering at Indian Institute of Technology, Guwahati since 2017. His group uses both quantum chemical and the molecular dynamic methods to predict the thermodynamics and transport properties of IEL and DES. His interest lies in the cosmos-based method and molecular modeling techniques, which will include both classical MD and reactive force field simulation, application areas including both renewable and non-renewable coal and chemical hybrids energy sources. He has also co-authored 2 books, CRE and Levenspiel, elsewhere, and other over 130 publications. His group has till date contributed around 900 data points related to the thermodynamics data point of IEL and DES mixture and is now available in NIST. Overall, he has guided 16 PhD and 22 master students, where most of them are involved in the application of green solvent to energy and environmental domain. He is currently the fellow of both Royal Society of Chemistry and Chemical Society. He is also served in the editorial board of Fluid Phase Equilibria. Please, Tamal Banerjee, sir, start. So you can start now.
Professor Saraswat for that introduction. So I'll just share my screen. Please let me know if you are able to, see the entire screen. Is the entire screen visible?
Yes, yes.
Okay, great. So, so I have 20 minutes, right?
Yeah, perfectly,
Yeah.
sir.
Okay, please, yeah. So the current talk of me relates to water purification, because the entire conference is based on the domain of water. So the molecular modeling. So what I will discuss in this current talk, I will discuss some thermodynamic insights and molecular modeling insights in the use of eutectic solvents for remediation of pharmaceuticals from wastewater. So I'll start with some introduction, then I will move to objectives, and then I'll use the molecular modeling tool, the molecular dynamic simulation using these novel solvents, and finally conclude. So, these active pharmaceuticals are found in one such effluent near a treatment plant in Hyderabad. So this is already reported in Journal of these hazardous materials. Sorry. So, these, as you can see, the range is outside the limits. So our work is a part that is from the quantum chemical basis. We want to see, is there any other than the adsorption, other techniques? How does the extraction works, the liquid extraction? So we have 2 phases. One is the aqueous phase, one is the phases which is the effluent phase. So any of these molecular modeling insight will tell us how a particular active ingredient is diffusing from the effluent phase to the solvent-rich phase. Okay, the effluent phase is primarily water-rich phase. So these are the solvents we have proposed study. So we have these called as eutectic solvents, or sometimes it is in general is called as eutectic solvent. What does this eutectic solvent imply? So eutectic solvent implies that you have a hydrogen bond acceptor and a hydrogen bond donor. When they are mixed together at a certain proportion, so it may be a liquid. So if you see those in the standard chemical engineering thermodynamics, you have a component A here and component B here. So if you keep on mixing them, at a temperature where you keep on mixing, so the point which is which is not white, there will be a mixture of solid and the liquid phase, but the one which is below this eutectic point is only a solid phase. So this is the temperature, the lowest temperature, when both these components are mixed together, they becomes a liquid. So outside this all part, these are all liquid. So what we have with this, we can formulate new solvents. Even if you have new solvents, each solvent will have different purpose. For example, if you prepare hydrophobic solvent, we can then use these solvents to entrap the pharmaceutical agent. So you can see the number of publications in this domain are increasing, like hydrophilic and hydrophobic both. So like it is increasing like almost exponentially. So that's why we have attempted to use these solvents for our case. Just a second. So we use molecular dynamic simulation. Those who are aware of techniques, I will not go into the details. What you do is you actually select a certain number of molecules. You select their initial coordinates, the number of molecules in the system, the force fields, then you minimize the system. This is the first step. You assign the velocities to all these particles, that is all the molecules of either water or with it the active ingredient and the solvent. You heat the system, so minimization is at 0 Kelvin, you heat it at a system temperature 298. So these, as you see in the right hand panel, you have different software to do this work for you. This NAMD, AMBER, we do it with NAMD, and we prepare the initial configuration with these force field packages, back them with Packmol software. Well, then we do our equilibrium dynamics in NPT or NPT ensemble, so as to converge this experimental condition. What do you mean by experimental condition? Because we know the water, or example for any other phases, we know the density. So we can compare whether the densities actually agrees with the reported. Then we do a run in the production dynamics, which is called the NVT ensemble, and we get the dynamic trajectories of how the molecules are diffusing. I will show a video later on where you will come to know how a molecule is diffusing from the effluent phase to the solvent phase. And the last step actually is analysis of trajectory, because it is something like when you do an experiment, you keep on mixing two compounds and then you keep it for some time. That is called equilibration. Same thing, we are doing equilibration. Then after that, you then do the analysis. Same here is followed, you will do the analysis of the trajectory. So whatever molecules are moving from there, what can we get? What are the different structural and dynamic properties? So we can say what are the interaction energies between the different constituents, the hydrogen bonds, radial distribution function, spatial diffusion, like that. There are some softwares which we use, Travis, VMD, etc. So I will now go to the results. So how to do this? I have just now repeated. Only thing is the using this functional theories and basis set. Then we use ample force field to generate this initial spikes for the ND simulation. Then finally perform and execute the ND simulation with this particular NAP 8.1 version, and we compute these properties: interaction energies, RDF, CDF, hydrogen distribution, mean square activity. So these are the different hydrophilic and hydrophobic solvents which we will be using. So we will only consider this part, lower part, and the particular pharmaceutical agent which will be used in this work is Internation. Internation water. So these are the hydrogen bond acceptor, octanoic acid, ecanoic acid. As you go for a long chain, the entire solvent becomes hydrophobic, but on the other hand, it becomes viscous. So when each of these are mixed with this particular hydrogen bond acceptor, that is DL menthol, to give rise to 3 different solvents. So what we did, we gave these 10 systems. These 10 systems corresponding to 10 different solvents. This is 1 solvent, 2 solvent, 3 solvent, and we mix them with this number of molecules, 30, 30, P, 180, as water molecules, 30, 30, each total 40 molecules. Like that, we studied several systems. This is separate solvent system S1 to S10. Okay, so these are the different hydrogen acceptor and these are the donors. Then we computed how they are interacting. So there are 2 different interactions, one on bonded interaction, the electrostatic and the magnet also. So the important thing of all these numbers is this value, total between the different hydrogen bond acceptor with the particular acid. So if you see this number is increasing, this numbers changing, 8.09, 11, 12, 13 and 10. Okay, so we went to this further, we increased it, and we went to proteoconate, pyruvate, levulinic acid, and then we changed the hydrogen bond acceptor. We saw these values to be very high, 22.87. It means when this is very high, it means the molecule is very much stable in the solvent. The entire solvent is very much stable. It will not dissolve back to the or leach back to the water phase. Because if you see the magnitude of the water with the water and with the itself with the DES solvent, you see the difference is almost an order. Okay, so that's why these two solvents, etanoic, rhodanoic acid, they are very useful for the extraction of the active ingredient. So what we saw from the interaction study is, we saw the non-bonded interaction energies between these, and we also saw that as you increase the hydrophobic tail of these molecules, we went to higher carboxylic acid, C8-acetyl, it pushes the water molecules going to steric hindrance. Then we found a relative stability factor. This is based on the interaction energy between the constituents of the solvent to the interaction of the constituent of the solvent with water and donor with water. So a stability factor ranging from 0 to 3.30 can be termed as miscible in water or unstable. It means if you use water and the solvent will leach out into the water. So only this octanoic acid, more than 3, decanoic acid, dodecanoic acid, they were emerged stable in water. For ammonium-based solvents, both acetic acid and octanoic acid were unstable in water. So we chose the first 3 solvents based on dodecanoic acid, decanoic acid and octanoic acid respectively. That's why we found this stability factor and we chose these 3 solvents as below the stability factor with octanoic, decanoic and dodecanoic acid, keeping the hydrogen acceptor as the same. So what are these combined distribution function? It means how are they interacting? This is what you have is, this is the ACE means the particular acid and water distance. So how are the distance between the acid and the water atoms? If it is higher, it means they are not related to each other. If it is lower, means lower and higher, the contour plots are given here. So these are the contour plots. So it means that the likelihood of having a distance of 2.5 angstrom will be, if it is green, it means we are lying in between this and this. So these are very much stable in this case. So the solvent and water are pretty much stable because the bond distance between the atoms of water and the solvent is pretty high. Same we also found for this, it is almost, most of them are blue. It means the one which is important are those which are green. So now it is almost 5.58. Because we are only concerned with the values which is around they are about the hydrogen bonding. So if you see this decanoic acid, they are also tightly bonded. This is within the solvent, this is the solvent with water. Same thing with the other octanoic acid with water, and this is within the solvent. So if you see more, it is mostly stable, so the system can be used for extraction. Now when you see the average hydrogen bonding between the different components, see acetic acid, water. So the highest number of hydrogen bonds is formed with respect to the black one. The black one means acetic acid, water. So these are not suitable. So the one which is having the lowest hydrogen bonding and the most stable. So like see the dodecanoic acid is pink. It is less than 1. So the amount of hydrogen bond between the dodecanoic acid and water is very less, so dodecanoic acid is stable. Same here also, you have the average hydrogen bond. So this is again you have your black one is important. So the black one, so hydrogen bonding between the components of the solvent, that is much higher in the case of pink one. So they are stable as a solvent. It is the contrary to the one which is water. Okay, so it means these solvents with octanoic, decanoic and dodecanoic acid, they are having higher number of hydrogen bond between itself. So it means they are highly stable. So we did an extraction of Newton PM through these solvents, and what we found is, we found a good total non-bonded interaction to be higher in the case of the Newton PM. Newton PM octanoic acid is 0.81 and DL menthol octanoic acid as compared to DES deuterium. So the entire solvent with the active ingredient is having a total non-quadratic interaction which is higher than that of the particular active ingredient with water. So it means it is preferentially extracted toward the solvent rich phase. So what we did, we tried out with different combinations. So what we did is we put some amount of active ingredient molecule inside the water phase and some molecules, the amount of molecules in the solvent phase. Then we mix them together and let the simulation proceed. After that, we computed how much of the molecule has diffused from the aqueous rich phase, that is water rich phase, to the solvent rich phase. So if you see the amount, this is the mole fraction in the DES rich phase and the water rich phase, which is for deuterium. So in the DES rich phase is higher as compared to the water rich phase. So this is closely agreeing with the experimental results. And then we also saw what is the radial dispersion function. What is the radial dispersion function? It means with the central atom of the active ingredients, which is here, oxygen of the deuterium, how many octanoic acid or how many constituents of the hydrogen of the solvent is around itself. So if you see the most number, it is closely around separated or is closely surrounded with the deuterium with DL menthol as compared to the black one, which is octanoic acid. So we can say the hydrogen bond acceptor is usually associated with a higher extraction. Same thing we can also see with when we compare with octanoic acid to DL menthol. It means see that the DL menthol octanoic acid are stable in itself, but when deuterium tries to associate itself with the DL menthol. This is again, so this is two-dimensional information, and what we have is a three-dimensional information. So it is like what is the bond length between the atoms of the solvent and the active ingredients, and what is the bond length of the same atom and the solvent. This is distance and this is angle. So the bond length is as shown. It is very much stable in the case of DL menthol. Okay, as compared to the distance is around 200 angstrom. Others are not important. The green ones are the one where the distance is less. So then this is the spatial distribution function. What is the spatial distribution function? Is that you have a certain like if this is the central molecule, which is the active ingredient, what is it which is surrounding that active ingredients? Here in this case, which is water, which is separating the active ingredient, but the yellow ones, the octanoic acid and the DL menthol, are closer. It may not appear to be closer because it is not a three-dimensional figure, but these are much closer to the active ingredient as compared to water. So it means it is preferentially solvated with the DL menthol. In terms of average hydrogen bonds also, if you see with respect to DL menthol, the average hydrogen bonds. So it means that out of every 100, 2 molecules are participating in hydrogen bonds, and you see for deuterium and DL menthol, it is the highest for octanoic acid. Again, it is a consequence of the solvent phase. So I'll just show you this video if it works. So we'll see. So the blue ones are the solvent phase, and the yellow ones are water, and you see for 4 molecules of deuterium. So this is the initial starting point of the simulation. So if you see how this, if you can see the video correctly, how this deuterium molecule is moving from the water-rich phase, that is yellow, to the blue ones, which is a solvent-rich phase. Now you see it's periodic boundary condition. So it means whatever you have been, it's going out of the box, it will again return back to this side. So if you see once the simulation completes, now you see this deuterium molecule is well inside the solvent molecule. See, it is well inside the solvent molecule. So initially you might have realized this particular molecule were totally inside the water. Now it is coming to the interface of the solvent. Okay, once it comes inside the interface of the solvent, it easily passes to the solvent phase with time. So see now you can also see no water molecule is going to the solvent phase. So it means the solvent is intact. So whatever we have predicted earlier, stability of the solvent holds true in simulation as well. So you can see at the end, you will see all the molecules are within. So not all are selected will be inside two or three molecules will be inside. So if you see these two, three molecules are inside the solvent-rich phase, and the other molecules are the interface of the water and the solvent phase for solvent-rich. So we can say that the extraction, the particular return PM molecule was diffused from the water-rich phase to the solvent-rich phase. So I will conclude my talk here. Sorry. So this is my talk summary. So we saw the empty simulation for the extraction of return PM with menthol-based depleted solvents. The pesticide showed a higher van der Waals interaction with DES components. Electrostatic component was higher in case of water-drug interaction. The radial distribution function and the combined distribution function suggest strong presence of both HBA and HBD in the coordination chain. The extraction efficiency was 42% for return PM, and the higher distribution coefficient and selectivity have been obtained for the DES. So right now I just want to comment, even it is 42%, so in actual practice we recycle the solvent. So if you recycle the solvent, this is the batch process you can say, then this particular percentage of return PM in actual experimental condition will increase. So average hydrogen bonding between the hydrogen bonding donor and the drug molecules was higher, which actually helps the active ingredient to pass from the aqueous phase to the solvent-rich phase. So these are one of the articles which has been published with this current work, and my student Navendu Pal did all the simulations. Finally, like to acknowledge InDACON 2022 for this conference, for MBM University Jodhpur for inviting me for this keynote lecture. Navendu Pal, my student, and the sponsor SPARK, Government of India, and the supercomputer Paramishan for the computational time. Thank you.
Thank you, sir.
So this is Navendu Paul who did all the work. Yeah. Thank you. Yeah. Thank you.
Thank you, sir. Thank you for this very knowledgeable, insightful lecture. So, are there any questions from the audience?
So can I ask one question?
Yes, please.
Yeah, sure.
How many times you can recycle this?
You can recycle means there is the issue is you have to separate out again the solute from the solvent. Okay, so we have not tried. We have only done the quantum chemical insights. But when you are doing, we have to recover the solute from the solvent. You again require an anti-solvent. So the anti-solvent will then take out the solute back, again you recover and go back to the solvent. So we have not tried the actual experiment with the recyclability.
And have you validated this, have you done this with the actual antibiotic traces?
Yes. It will be on the pesticide. We have also done with the antibiotic and antifungal drugs, which have not, the results have not been showed here. So we actually compared, if you remember, I have shown you the extraction ability and compared it with the experiments, okay, at a particular composition.
You are doing this on the simulated water or the actual water?
Yes, it's a simulated model. It's a simulated. We have done only the simulations, yes. But the experiments were done from in our lab only, and some were performed or taken from the literature, reported literature. Yes.
And you take pure pesticides or the commercial ones?
We have used pesticides only. The pesticide means commercial. Yeah, nitrogen PM is one of the pesticide. Yes.
Okay, so thank you, sir.
Any more questions? I think there are no more questions at the time, sir. So on the behalf of the organizing committee, I would like to thank you for being with us and gracing us with this educational lecture, sir. Thank you, sir.
Thank you. Thanks a lot. Yeah. Thank you.
Very informative talk. Thank you, sir, for a very informative and very nice talk.
Yeah. You are. I mean, if anybody have any other query, you can always mail me. Yeah, I will be happy to help. Yeah, sure.
Yes, sir. Definitely.
Thank you.
Thank you, sir. So moving on to today's program. Next we have a lecture from Dr. S. Shaktivel. The topic of the talk is an approach to industrial decarbonization with hydrogen through water splitting technique. Before we start with the lecture, I would like to present a very brief introduction to Dr. Shaktivel. So Dr. S. Shaktivel is working on energy transition and decarbonization with responsibility for the evaluation of emerging technologies and commercialization. He has experience in process engineering, technology analysis, screening and selection, techno-economic analysis, pilot setups, process hazard analysis, basic applied and market research, and powder and science technology. So with this very brief introduction, I would like to invite Dr. Saktivel to give us or bless us with his lecture. Please, sir. Sir, I think you are mute, sir. Yeah. Please unmute yourself.
Yes. Are you able to hear me?
Yes, yes. You are now audible.
Are you? Yeah. Can you see my screen now?
Yes, it is visible, sir.
Okay, good. Thank you so much. Thank you so much for conducting such a wonderful international conference. Today, I am going to talk about that how the water, the major role for hydrogen economics. Currently, there are various emerging technology for the low carbon, or we can say energy transitions emerging. So these technologies, how much of energy and water consumption, what is the role of the water experts here? So I am going to explain that very extensively. And the purpose of the presentation is to explore the connection between hydrogen and water, as a hydrogen developed as a key energy source in the energy transition to the low carbon economics. So water and energy resource are significantly material foundation for development of human society and powerful driving force for moderation process. However, in the contents of the global climate change and the increasing population, we are facing many problems regarding the demand of water resource for society and the industry purpose. So before going to the presentations, this is one of the quote is written by AD before that. Water is life that comes from rain. The sign rains, our duties goes to into wine. This is written very long back. This is one of the importance of that water for human life and industrial level. So today I am going to talk about these six chapters here. That's the contents. Before going to the contents on the water for hydrogen production and technology readiness level, and hydrogen from salty and wastewater, and solar desalination and takeaway from this presentation. So as we know, water plays a major role in all energy sectors, like energy sector, for example, refineries, power and textile, beverages, automotive industries. Currently, these are the existing industries. Currently, what happened, some of the low carbon technologies like wind energy, solar, these kind of emerging for a reduction of the carbon dioxide and the energy transition to reduce the global warming. Various reasons we are working on the industrial point of view. Here, these wind and solar power technologies are required little water. Others such as biofuel, concentrating of solar power, carbon capture technology, storage and nuclear power are relatively higher water intensity technologies are there. Our long-term ambition to depend solely on renewable energy by 2040 and 2050. This is for Paris agreements through solar, wind, tide, hydropower, etc. for generation of renewable energy. Suppose if you are producing surplus of electricity, if you are producing surplus of electricity, such will be stored in the proper way. Whether we can give a battery wise or we can convert as a chemical. In this contents, the hydrogen expected to play critical role in the future as an energy carrier. That is one of the energy carrier identified. One of the challenge of hydrogen economic is a sustainable level of water consumption it involves. As part of cooling needs, every kilogram hydrogen documentically involves 9 liter of water in the electrolysis. The clean or renewable energy plays major role in the economics. So today we are going to talk about how we are playing that addressing this water. So these are the recent emerging technology for energy transitions. For excess of electricity or a clean electricity will be produced through the various chemicals, power to gas, power to chemicals, power to liquid, power to heat. So here flow diagram is show there are two fields of mandatory for that to achieve this the clean carbon or chemicals. One is here clean electricity, second is here water, one of the things. So today is here we are focusing on the water. Many technology has been developing and utilizing renewable energy against fossil fuel application. However, some of the systems still require a clean fuel or clean chemical instead of electricity. Hence, the produced electricity from the renewable can be converted to gas, synthetic fuel, chemicals, industrial residence heating purpose. This is called, we can say, power to X or power to gas technology. You see the right hand figures depict the renewable electrical power to produce gaseous fuel, like through hydrogen or methane, liquid fuel, methanol, dimethyl ether, synthetic, and industrial feedstock and industrial residential heat by the various technology you can see here. So why we are going for hydrogen? So what is the purpose? How we can relate with the hydrogen and water? So that's a key point might be arised on ourselves. So why we are choosing as a hydrogen? Hydrogen is a main 4 point. This is here there is no carbon content which emits only carbon emission free fuel. Point number 1. Second thing is the highest energy density in that among the that is called the blue hydrogen. Basically, another additionally add the energy also, but the water also it required for further process to produce a blue hydrogen. Here, third technology, today I am focusing on the water electrolysis. It is documentically, it's a water, demineralized water I told, 9 liters, blood plus electricity and breaking hydrogen and oxygen we are splitting through water splitting technology. So Siemens, Hydrogenous, Nel, there are various people are they're developing that technology. They're selling them across the globe. India also we are implementing many water electrolysis process here. So sometimes we are using the tap water also. Tap means potable water. We can say the 15 liters per liter of hydrogen is required to produce 1 kg of hydrogen. That as a water experts we got to look about how we can reduce and increase the efficiency of these things. So I am talking about that. What you understand that basic principle of alkaline water electrolysis we want to understand here. The water electrolysis technology is splitting water into hydrogen and not grid energy. Simply, water electrolysis consists of anode and cathode, which is immersed in the electrolyte solution. But we can say electrolyte solutions means alkaline solution, potassium hydroxide or sodium hydroxide. We can use it anyone. Hydrogen produced half mole of oxygen also generated. See that this is basic beautiful reaction. We are splitting 1 mole of hydrogen we are getting, half mole of oxygen we are getting from 1 mole of water molecules. Things theoretically we record 9 kilogram of water. So currently that hydrogen will be used to ammonia industries, polymer industries, resins we can use as a chemical sector. In the refinery sector we can say cracking purpose there. These are the 3 major routes which is a carbon intensive process. It is around 96% of hydrogen currently produced from methods. Only the 4% of hydrogen produced from the renewable or electrolysis of water. So here, what will happen? Currently, these are the existing application, but currently the hydrogen carrying the carbon dioxide and reacting with this green hydrogen and producing steels also. Then power generations you are using and stationary power, backup power they are using here. So there are many emerging, many emerging technologies are emerging based on that green hydrogen. Green hydrogen emerging, another technology is developing. It is consequently is developing and improving our society in terms of energy. Here, overview of another electrical arc furnace. There are both of the steel industries. Glass melting industry also they using electrical power generated by oxygen using here. So currently, what will happen? Currently, oxygen is produced from air separation units is through cryogenic heating. You want to do produce desalinated water, then desalinated water is sent to that. These entire routes will be a cost and energy intensity process here. Seawater to at DM water production. Some certain we can discuss that. That's also in the presentation here. Suppose why we cannot produce from salty water here directly from salty water. We can take the seawater, 35 percentage of alkalinity we are maintaining. So why we cannot use that alkaline water, saline water from that? That we are thinking. Recently, Stanford Research and IIT Madras Chemistry Department under IIT Kanpur, there are IIT Bombay. These institutes are already having developed a prototype hydrogen generator from seawater which is powered by solar power. What is the main correction here? Efficiency is one of the major problems here. Currently, what we are using water, what their researchers are reporting here, we are getting very low, less than 5% of efficiency only we are getting. Directly we are using the seawater or saline water. Then the electrodes and the mechanical part, the challenging and the corrosion of the mechanical electrodes, membrane, they are very challenging here. So we want to optimize that the saline water to bring, instead of bringing the demineralized water, we can bring directly from the seawater to that all the having water experts. Everybody jointly we got to work and reduce that cost and the corrosion, the engineering problem also here. The researcher discovered that is a coated anode with a layer. Some researchers also coated the anode. But what will happen again? The negativity charge is a displaying problem that the current is not flowing properly. That finally it's not that much of expected results not coming here. So still there is definitely next few years will get, before 2025 will get developing a salty water from hydrogen. Next method is hydrogen production from the wastewater. That is also one of the interesting things. There are the two technologies available correctly. That is called light dependent reaction and light independent reaction. We can say like that. So light dependent reaction is a biophotosynthesis or photofermentation. They were taking the wastewater. They are doing the photosynthesis. They are using the catalyst. Then again the problem, the catalyst that the yield is very less. Again we want to work. These are the TRL level about less than the 4 technology readiness level for these technologies. Again, the second method is a light independent reaction, the dark fermentation and the microbial electrode hydrogenation cells also. There people are working on that. So still we have to work on this tremendous our effort on these areas. We have to develop hydrogen production from salty water, hydrogen production from wastewater. Suppose in this thing, if I get it from the hydrogen, so we can make a clean economic and a carbon clean the hydrogen economic we can produce for India. So these are two water we have seen currently, but solar desalination is also industrially they are using. For example, in Middle East there are various technologies that are using. We want to optimize the DM package, demineralization unit also. Here there are various techniques as we know very well. The conventional thermal methods includes a multi-effect distillation, multi-stage flash distillation, humidification, dehumidification, mechanical vapor compression, thermal vapor compression. These are the conventional thermal method of desalination of the water. Here another method is a membrane process. We can say there are 3: reverse osmosis, as you know everyone, membrane distillations, electrolysis, electrodialysis, reverse. These 3 techniques currently they are using demineralized to production of demineralized water. Here we want to integrate the solar power with the desalination. There are 2 methods we can do: direct and indirect. See, desalination process already we explained. These are the direct solar. I'll show the matrix here. See, these are the matrix. So there are 4 technologies which is connected to the direct solar desalination. See the photovoltaic, it's available mechanical vapor compression and the reverse osmosis ED you can correctly, which is can connect that photovoltaic electricity power. These are the technology matrix to connect that electrolyzer here. This is a table. We derived this kind of analysis here. The conventional methods of, for example, I'm taking. There are 5 technology I compared here. Here I'm taking. Here, for example, I'm taking here our reverse osmosis. If we are installing reverse osmosis, the product cost is around zero point 0.4 to $1.7, which is depends on the direct, indirect, annual operating cost, capex, opex. Then product cost, it depends on the quality of saline water, desalination process, and the technology. We included the technology supplier, location, and solar intensity, plant size. Everything based on that cost we arrived. Here there's zero point 0.4 to $1.5 per meter cube of water. Cost is coming here. Suppose the same unit, if you're connecting the solar desalination, the cost is around increasing around 4 times. It's like approximately about $4 to $8 per meter cube of things. That's we got to concentrate how to manage this kind of solar desalination cost. This will be higher cost compared to the conventional methods. Again, I'm coming back to these are the things. I'm coming to the takeaway for end of the presentations. At the present, hydrogen production system are heavily depends on fossil fuel system. This system must switch to renewable fuels to make hydrogen's 100% clean fuel sources. There are the 3 key priorities for water to be considered here. First of all, safe and secure drinking water for all. That's a municipal purpose. That's the point. Then second is healthy and acoustic system should not be disturbed or should not be, because of very important to how we are drinking water. That much of importance we can give aquatic ecosystem for environmental protection. Then third one, industrial purpose for sustainable economic, for the agriculture, energy, resource development, industrial, water it can be. For these things, so the following 3 key steps to be needed to create viable for hydrogen economics through water or renewable energy. First of all, strategy. The government and stakeholders and manufacturers should have the clear picture of hydrogen supply and demands over the long term, so that we can plan investments. Recently, our Indian government's also launched a hydrogen economic website. They're given to more than 10 crores of rupees. They're awarded for through DST funded project. Almost all Indian institute and research laboratories, all companies working on the hydrogen economy. Already directly, indirectly, the Indian government is supporting to us. So policy, we can say government must create attractive policies here. Attractive policies along the subsidies for use of hydrogen fuels that helps to producers, suppliers. What that means here? Suppose carbon credit or carbon intensity, that wherever they do those use your green electricity or green water, green hydrogen, green energy, the government give the product attractive policy for that improvement. That's also their plan. They're doing like that. Infrastructure development. The development of infrastructure for hydrogen economics needed include the large scale production, storage, and transportation. This is jointly we got to how the storage of hydrogen, liquid hydrogen storage, gaseous storage, transportation. What is happening? No, hydrogen is one of the lowest energy, lowest density here. For example, we can say the gaseous density is 0.089 normal meter cube per hour. This is not normal meter cube. So this is a very lowest density we got to work, but it has highest energy density for 120 megajoules per kg. That's we got to challenging for providing infrastructure such kind of gases here. So research and developments, yes, definitely, as we are jointly more research must be done on hydrogen economics, entire supply system to reduce the cost and improve the performance, particularly for electrolyzer, fuel cell and membrane, etc. through things here. So finally, I'm concluding here. Jointly, we have to improve our efficiency and reduce the OPEX, CAPEX of the DM water and water-related water-related other activities. So it definitely our boost through that energy transition. India will be moves to the energy transition part. Thank you to all.
Thank you, sir. Any questions from the audience?
Am I audible?
Yes.
Okay, so at the Tata level, what kind of technology you are focusing for the hydrogen production, and what is the TRL level?
So currently we are focusing on that water electrolysis technologies. The priority we are giving because of the green hydrogen. Then we are second methods also blue hydrogen also we are focusing on that. Blue hydrogen it means existing process hydrogen process we are implementing the carbon capture
Blue
unit.
hydrogen.
So
What's the blue
currently.
hydrogen? Sorry, I couldn't get what is the blue hydrogen.
Yeah, that's okay. I explain you. There are three colors of many colors. Their experts are saying this is a gray color. Second is a blue color. Second is a green hydrogen. Gray color hydrogen it means that that the color all the colors is based on that production methods, production routes, which is which feedstock we are using. For example, hydrogen is produced from natural gas or crude oil coal gasification. What will happen? All the thermal cracking or all the chemical process, hydrogen is come out from the methane CH4, carbon dioxide emitting to the atmosphere. That is called the gray hydrogen. Suppose in the same process, if installing the carbon capture units, the capturing what are the how much of carbon is captured, which is produced by the hydrogen production, that is called the end product called the blue hydrogen. The green hydrogen it means through water and electricity. There is no carbon sources. Here we have green hydrogen. That's a color coding only. That's all.
Okay, so in that process, suppose you are using like what kind of electrodes you are using there?
No. Actually, we are engineering consulting companies. We are consulting. We are to the client only. We are not developing any electrodes or electrolyzer here. We are consulting company.
Okay.
We are engineering company. We are doing engineering. So all the technical information we are having tie up with various OEM vendors. We are getting that information. We are suggesting to the client. That's all.
Any other question?
So a wonderful talk, very informative and very elaborate. So is there any possibility of using recycled water for electrolysis?
Yes, ma'am. Yes, definitely. All the OEM also, we are discussing with many people. But the electrodes, that is challenging on that electrodes, is a corrosion is happening. Actually, current electrolysis working on the pure demineralized water only. Even the hardness also very limited. The specification it depends on the technology. There are more than 20 companies are developing the electrolyzer. So that's why we are interacting, we are emphasizing to all the research institute or anything. So we want to develop, we are interacting other academic institutions also. We want to develop their raw water, tap water or salty water or wastewater. That kind of, we can come from the through research only. Currently, definitely we can use it, but the efficiency is not that much. Already what happened? No, already the electrolysis not efficient process compared to the conventional process. Only we are getting advantage of a carbon-free process. That is one more advantage. Again, one more advantage why we are taking already the electricity price, renewable electricity price is reducing industrial level. So already we are producing last few decades viewers $60 per megawatt. We are getting around $20-25. We are getting renewable from the renewable. The tariff recent reports are saying, and InDA reports also saying like that. So in these things, they are taking advantage of water electrolysis. So we want to focus on that water point of view. Suppose if we crack any technology for water, desalination water, salty water, that's this definitely it is a good for us. Thank you, ma'am.
Any other questions from anyone? I think, sir, there are no more questions at the time. So on behalf of whole organizing committee, I would like to thank you for sharing your knowledge with us and being here with us in this conference. Thank you, sir.
Thank you.
In Industry and Environmental Technology and Management, a diploma in Industrial Safety, a BE, a Government of India Certified Energy Auditor. He is also an ISO 14001-2015 Lead Auditor and Responsible Care Lead Auditor. He has more than 28 years of experience in chemical industries covering safety, health and environment and manufacturing. Last organization where he worked was Messrs. UPL Limited and group companies. As on today, he is working with Mrs. Aarti Industries as Head Corporate Environment since April 2019 under Sustainability Department and supporting to 17 manufacturing units. So with this brief introduction, I would like to invite Mr. Karhale to please give us the today's lecture. Thank you, sir. Please, sir.
Thank you so much for a lovely introduction. I will share my presentation. My screen is visible?
Yes, it is visible, sir.
Voice also clear, na?
Yes.
Yeah, first of all, thank to MBM Engineering College, Jodhpur, Indian Desalination Association, and InDACON 22. Really, you have given us opportunity to present our industrial best practices to here. Thank you so much. So I will cover recent technology for water, wastewater treatment, and case studies Aarti Industries Limited. Here, Aarti Industries Limited is one specialty chemical manufacturing located in particularly Gujarat, Maharashtra, and Madhya Pradesh. So ZLD, because ZLD is the one solution to really conservation of water as well as pollution prevention technology. But whenever you want to ZLD unit, you have to do qualitative and quantitative assessment so that you can achieve that performance of ZLD. Once ZLD, then you cannot discharge water to outside. So that is the one condition for particularly ZLD. So because ZLD need particularly pre-treatment, effluent treatment, and reverse osmosis and thermal process like multiple evaporators. Yeah, right now new technology like MVR also there. So that much you have to consist for ZLD, and for qualitative and quantitative assessment is a very important before going to ZLD unit. But ZLD you can achieve your effluent 100% recycling. Generated salt you can send to landfilling, which is available right now in all Indian states. So we'll see the advanced pre-treatment like advanced oxidation system, which is available in chemical industries. So advanced oxidation, we can remove the problematic organic matter that can reduce, and you can increase your COD BOD ratios also, and that can be helped again followed by biological treatment and zero discharge unit also. So right now, Indian chemical industry practicing photochemical oxidation, catalytic vapor oxidation, ozonation, electrochemical oxidation, and penton oxidation. But penton is a easily available treatment in chemical industry. And major industries because it is a good H2O2 and ferrous sulfate is a good oxidizing agent. That's why most of the industries following the penton processes. We will see here a penton treatment. Penton treatment is a production of the OH radical after using this chemical treatment like H2O2 and ferrous sulfate. So we have to maintain pH about 3.5 pH for particularly oxidizing it. And there is a disadvantage also because we have to maintain pH is acidic. This is a costly method, and H2O2 is a highly oxidizing agent. So storage also, handling and storage also one difficult part. So whenever you want to consider penton reaction, you have to do always lab and pilot trials so that your commercialized performance will be the very good. Otherwise, many industry has directly gone to commercial part, and they have failed their particularly penton treatment. So whenever you want to introduce in chemical industry penton treatment, you have to do lab trial and pilot trial. Jar test also we have to do particularly steam, and then only you can go for commercialize. And here is a for penton, pH and COD parameters are very, very, very important. Along with COD organic matter, there is a reduction in ammonical nitrogen also during penton processes. Color improvement also there. So this is also one benefit for penton treatment. And penton followed by effluent treatment plant. Effluent treatment plant is really remove the organic content, suspended solid, ammonical nitrogen, color also. So this consists preliminary treatment, primary treatment, biological treatment, and tertiary treatment. Because this is a combination of major effluent treatment plant established in India. So preliminary treatment is really both physical operation and as well as chemical operation. Primary treatment also physical operation as well as chemical processes involvement. Biological treatment have aerobic, anaerobic processes. Aerobic processes is the actuated sludge processes, membrane bioreactor, MBBR and SBR, sequential bioreactor. Anaerobic process also have in the chemical industry, but there is a BOD COD ratio is above 50%. Then only you can utilize this anaerobic processes. So here also I am recommending that you have to do proper treatability study for each stream. But chemical industry having one unit about 10 chemical plants, different processes. Different processes have different characteristics also. So stream-wise treatability study is a very, very important before establish your any treatment plant, biological treatment plant. So that's you can do at a lab trial as well as a pilot trial. So you can, whenever you are commercialize that treatment plant, you can succeed there. So this is one I'm giving here ZLD equipments like penton reaction is there. Here is a biological treatment, activated carbon for tertiary treatment, multiple effective operator. This is a combination required for ZLD units. So one more area is a very good area and simple. We can recycle our water because water is a really precious part right now. Because here also I read that 71 million people still find difficulty to clean water. Really, I am appreciated your theme also. Jal hai to kal hai. So this is sewage treatment plant can be utilized for industrial purpose, even though residential purpose. And easily you can recycle that water for green belt development as well as cooling towers or other utilizations like flushing and all these things. So this is a simple equipment right now in market available in compact condition. So you can install at your residential area also and industrial area. This is like effluent treatment plant. But in STP sewage, there is a BOD is a very high. That's why you can treat it easily, and there is no other impurities which can harmful to biological treatment. So you can easily install this part, and you can recycle this treated water for particular some purposes. So ETP and particularly STP available in the market. This is a conventional activated sludge process. So if you see this collection tank, primary treatment, anaxic tank for particularly ammonical nitrogen reduction, aeration tank for biological compound like COD, BOD reduction, and post there is a dewatering of sludge, and there is a tertiary treatment like ultrafiltration, sometimes activated carbon, sometimes chlorination, sometimes RO systems. MBBR is one more technology. This is a really compact technology. Can reduce your particularly cost also, carbon footprint, power reduction in there. And right now this is the advanced technology available in market, and we have also installed that. MBR also one more technology you can utilize into chemical industries. Membrane bioreactor. Here, tertiary, sometimes tertiary treatment is not required because you are utilizing this MBR at the end of the biological treatment. So we'll get suspended solid maybe below 20 ppm, and that can be really recyclable water. This is also compact tuning. Again, carbon footprint reduction available, and clean water you will get from MBR. Reverse osmosis. This is a really water recycling equipment. Right now, forward osmosis also new technology introduced. This is a utilized membrane. So we will get about first stage 75% recovery for particularly treated water from ETB. PDS level is about 5 to 10,000. Then you can, right now there is a available membrane technology available in market for HPROs, high pressure ROs. That again you can get 60% recovery. So we'll get about 99% recovery for but generated reject you can send to multiple effective operator MVR technology. But before introduction of RO system, you can require pilot trials. Lot of agencies available outside. If you send your sample to them, they can do treatability study so that during commercialize it will not be paid. Multiple effective operator, multiple vapor compressor system. This is really energy efficient equipment. Before that establish this technology, we are utilizing only 4 C operators, single stage operator. There is a requirement of 1 kg steam for 1 kg operation. Here we require only 0.3 kg steam for 1 kg effluent operation. So here also I am recommending that you have to do pilot trials and parameter is a very important like silica hardness, turbidity, free chlorine, ammonical nitrogen. You have to do pre-treatment for particularly before sending to multiple effective. Then thin film dryer ATFD. This is for a dewatering of concentrated multiple effective operator effluent. So you can achieve the 10% moisture here, powder form. You get your salt plus sludge acid powder form. And then you can send that to landfilling sometimes if you are really that usable into co-processing into cement industry like this. You have to do that particular salt and condensate you can recycling back into the processes. Very important whenever you are to want to run chemical industry and generated effluent you want to treat. So we have proper segregation and treatment methodology. This is a type of particularly effluent characteristic, and there is a criteria and preferably treatment methodology. So if BOD is more than 30% of COD, low COD and low TDS parameter, then biological treatment system can be recommended. If BOD is less than 30% of the COD, then pre-treatment followed by biological treatment. Pre-treatment can be chlorination, ozonation, penton reaction. If total nitrogen is more than 10% of BOD in aerobic system, then pre-treatment steam stripper can be followed by this biological treatment. If high COD and low TDS, if COD is due to VOC, then stripper because VOC is always solvent, most of the solvent that can be recycled and recovery and recycled back into the your processes. So stripper followed by biological treatment. If BOD is low, having toxicity, so chemical treatment like penton, chlorination, that system can be utilized and increase your BOD, COD ratio, then followed by biological treatment. Low COD, high TDS. So if COD is not due to the solvent, then you can utilize membrane forward membrane separation RO system, multiple effect followed by biological treatment or condensate treatment. Low COD, high TDS. If COD is due to the compound having high boiling point, then you can directly utilize the ME. Yours that low COD can be goes into salt. That is acceptable to landfilling criteria. If COD is due to the compound having low boiling point. Then ME followed by condensate can be treated to biological treatment. So high COD, high TDS. If COD is due to the compound having low boiling point, slipper plus ME followed by biological treatment for condensate. High COD, low TDS. If CV value is about 2500, then you can send to co-processing into cement industry. High COD and low, high calorific and solvent. High chloride, if you have 4%, then cement industry is not allowed. So you have to go for incineration. If utility water, like cooling tower blowdown, boiler blowdown, you can straightforward go for RO followed by ME and ATP. So that 100% water can be recycled. Sewage already we have discussed. So I have already discussed importance of treatability. This is a very, very important part before you have to go for commercialize your lab trial, pilot trials, and then only you have to go for commercialize. Then only your all system, effluent treatment system will be really good the performance. Otherwise, many industries have failed also due to this. They have not taken pilot trials and lab. So RT industries already I had discussed about we have 200 products, 400 global customers, 700 domestic customers. We have 16 units and 10 units we have ZLD and about 5,400 employees. So company if you see this, we have ISO 45001, ISO 14000 that is for environmental management system. We have responsible care initiative company. EcoVadis we got gold award. So like this we have accreditation. So our approach for environmental management for sustainability is the importance many reasons including environmental area. Environmental performance integrated part of R&D technology. But this is a very, very important. If you want environmental performance improvement, so need help of R&D technology, process and operation. Only one environmental engineer cannot be improved. So this is a combination always required. Whenever you want to introduce new molecule, then R&D help you have to design for environment. So that work start from R&D technology area. R&D work on environment because there is a upgradation of technology in market. So that is a very, very important to check your existing practices and introduce new technologies. Warehouse practices right now is a 5 R's: reuse, reduction, recycle, decoder, source reduction. So waste minimization and conversion into valuable products. N5 treatment, because if you are not ZLD possible, then N5 treatment is a very, very important because right now there is a lot of rule and regulation from government of India. So we have to achieve that. MIS for particularly, you have to discuss all issues with the top management. Then that is some again additional improvement. ZLD unit 100% compliance. This is required for chemical industry. Right? So approach at AIL. If you see this contribution of carbon footprint, so more carbon put in an incineration treatment and contribution of carbon. You see the last two very costly as well as large carbon. So our approach is how to treat this particularly incinerable waste, ME waste effluent into ETB plant. That is approach, and we have such subwares. We'll take that example. So water management at AIL, because water is a very precious part right now. So we have 16 units. Out of 16, we have 10 units as ZLD units. Or we are sending to some treated effluent to again to CETP for further treatment and disposal to deep sea. So we have ZLD system with consisting of particularly pentown reaction, biological treatment, followed by RO system, ME and ATFT, and a few STP we have installed for particular units. We have condensate recycling to boiler, steam condensate recycling. About 50 to 60% we are steam we are recycling back in. So we have achieved ZLD by two routes. One is the first pentown treatment, ME ATFT, then condensate going to effluent treatment plant, then RO system, and permeate we are recycling into cooling tower and other process. Second route is a activated sludge process. Then RO, cooling towers, permeate we are utilizing cooling tower. Then RO reject going to ME and ATFT. Utility RO, and then again we are recycling back into that particularly, and salt and sludge sending to particularly land side. So this is a pre-treatment we have like a pentan ozonation system. So effluent treatment plant, particularly treatment scene. This is a biological treatment. This is a RO system. The multiple effective operated and ATFP system. So we have STP plant also. We have soil biotechnology also in STP, MBR STP plant. So benefit of ZLD, significant reduce the risk of the sanction within the standard level. Like there is a compliance part also we can achieve. Installation of ZLD system caused a reduction of fresh water consumption. So we achieved 33% water we are taken from this ZLD unit. Reduction of dependency on local water sources, minimization wastewater discharge, and reduce the dependency of CATP, because many times CATP having a pipeline having maintenance issue, and you have to stop our production. So removes many environmental issues. Propose expansion easy to take clearance from authority. You get environmental clearance very easily from authority whenever you are ZLD operating. So water consumption is our water specific water consumption withdraw reduction for 1920 to 2021 2.7 to 2.65, and if you are recycling percentage, if you see in 20 we have 34%, right now is a 40%. So that much we are giving the importance of particularly water conservation and water recycling purpose. So if you see this figure of last year, so our water requirement is like this, and we are recycling about 7,39,000, is about 40% of particularly year. So this is a multiple effective operator. Other initiative like wastewater recycling is using scale band system. We have introduced one scale band system in cooling tower. So we can concentrate our TDS level from 3,000 right now in practices to up to 50,000. Steam condensator we already discussed. Sewage water treatment, water harvesting system. We are really next year we want to conserve water about 10,000 meter cube from water. Right now we are about 1160 kLD from rainwater. Next year our target is about 10,000 meter cube for particularly next monsoon season. So waste management also, other conservation waste valuable products into like we have waste is HCl, we are converting into calcium chloride. Spent sulfuric acid we are converting into single superphosphate. Nitrogen oxide we have byproduct nitrate sulfonic acid. Process residue we are giving to processing right now into cement industry. We have generation about 5,000 metric ton. 100% we want to send to processing as an alternate fuel to them. They are using right now coal, so this will be the alternate fuel to them. The fly ash utilization for brick manufacturing. So this is 100% right now going to for utilization of brick manufacturing. So if you see this, our generation is effluent is 2,050 KLD per day, and we are recycling about 1,700 KLD back into the processes. There's a big work because ZLD maintaining also very difficult to the industry. Proper segregation and treatment methodology. Thank you so much. Any question?
Good morning. Am I audible to you?
Yeah. Yes, sir.
Yeah. So it was really very informative lecture. I thank you very much for this. And the second thing is, I want to know one important thing. There is, if the water has high COD and high TDS, So in that case, what is the installation cost and the running cost of ZLD plants? A rough idea.
Correct. Rough idea is like this. For penton required about if you have high COD, high TDS, you have to install penton as well as multiple effective operator, ETP, and RO system. This much required for ZLD if you have high COD, high TDS. So you can say 5 rupees per 4 to 5 rupees per liter required, particularly penton. About 1 to 2 rupees is required for particularly multiple effective operator. About 0.4 rupees required for particularly RO system, and about 0.3 rupees required to ETV plant. So if you combine that, then you will get a cost per particularly. So you can say
10 rupees around per
about if you want to ZLD, then about 11 rupees, 10 to 11 rupees required for high COD, high TDS
okay.
per liter.
That is the installation cost.
That is the operation cost. Installation cost may be about, but that is depend on how much quantity you have.
Yes, of course it depends on how much we want to plan for this. 10 rupees per liter
Hello.
is the operational cost for this.
8 to 10 rupees you will get cost per particular core combination like penton, then ETP, RO, ME.
Okay.
Operation cost. And how much quantity you have. If you have 100 KLD, then maybe required about 20 crore to installation part, particularly all these things. If one example 100 KLD, and if your COD is about 30,000, 40,000, TDS is about 10 to 20,000. For 100 KLD, you may be required 20 crore capital investment, and OPEX is maybe about 8 to 10 rupees per liter.
Okay. Thank you.
But if you calculate carbon footprint, then about 6 times. If you are only effluent treatment plant and you are discharging to deep marine way, then only 6 times cost will carbon footprint will increase if you want to maintain ZLD units. But there is a compliances part also very important, and conservation, water conservation part is very important. That's why we are going for ZLD unit. There is a lot of problems with pipeline, discharge pipeline as well as CETP. They are not maintaining. So we are avoiding that part, and we want to recycle all precious water. That's why we are producing ZLD units. Yeah, sir. Yeah.
Thank you, sir. Any more questions?
So wonderful talk and very like you have done a lot of. I must congratulate Aarti Industries. They're doing really good work. So just a small question: are you working something on if there are heavy metal ions in the wastewater? Heavy metal ions.
You have heavy metal in particularly effluent, na?
Pardon, sir?
You have heavy metal content effluent.
Yeah.
Most of the chemical industry having heavy metals like in ppm, maybe about 10 ppm, 10 maximum, because they are utilizing raw materials, some heavy metals content. Some. So we have primary treatment with lime addition system. There is a precipitation part happen, and that going into stabilize that particularly heavy metals, and we are taken into sludge along with that the primary sludge with the dewatering system, and that generator sludge we are sending to again landfill inside, and there are most of the industry accepting that criteria, landfilling criteria for heavy metals.
So, but that doesn't remove the heavy metals.
Some industry having heavy metal like catalyst, they have individual system for particularly precipitation and recycling back into the same processes. So different precipitation processes for particularly metal, and then again recycling it back into.
And what about plastic industries?
Plastic industry, right now there is a government has established a good notification what type of plastic you have to utilize, how much micron size utilization. So that practice, that notification implementation part started in chemical industry. Pure plastic industry, they have banned, yeah, maybe stopped manufacturing also, particularly 90 micron size plastic generation. And they have to recycle. And you have to register, each industry you have to register in CPCB site, and you have to give plan for how to recycle it. Your product is going into 10 states of India. Then you have to recycling methodology you have to submit to Central Pollution Control Board. So that part is implementation part has started right after this notification. And
it's an organic waste.
Yeah, ma'am. Yeah.
Basically, the plastic they are giving organic waste. So can't we degrade that somehow?
Right now, there is a degradation and utilization like petrol, diesel manufacturing from plastic. Some recycling part has also started of plastic. But industrial practice, if you have contaminated plastic, you have to decontaminate that plastic generated plastic and send to converter, means scrap dealer. Those have that particularly practices like granular manufacturing, and that granular they are sending to again recyclers, plastic manufacturer. So that practice is happening in industry. But many other practices also started in India, like plastic to particularly utilization of road also. Many plastic to diesel also.
But that is the recycled. Basically, that is not from the effluent. It's basically the recycled one.
Yeah, that is recycling. But industries, they have practices like decontamination because a lot of contamination there due to chemical. So we have to decontaminate internally and then give to granular manufacturer. That granular manufacturer given to recyclers. That practices right now. And if you are going our product with plastic bag with other state, so we have to submit our plan to how to recover that all plastics. So that plan also establishing going on right now after this notification, CPCB notification. Yeah.
Thank you, sir. Any more questions? I think there are no more questions at the time now. So on the behalf of the organizing team, I would like to thank you, sir, for this insightful and educational lecture. I believe that all of the audience would be benefited from this lecture. Thank you, sir.
Thank you.
So towards the end of this keynote session, I would like to request Dr. Anupama Sharma ji to please conclude this keynote session.
So we had 3 talks in this session. All 3 were very informative. Like starting with, we had modeling of modeling simulation using eutectic fluids. So again, it was a very informative talk. And because I am working on pesticides and removal of pesticides and heavy metal ions and drugs, so I felt using eutectic solvent, it was a great initiative taken by IIT Guwahati. The second talk was on hydrogen from water using electrolysis. Again, a very new and very recent area of interest. And the third one was it was a more practically oriented talk. We saw what the Aarti Industries is doing, and I must congratulate that they are doing wonderful job in the area of wastewater treatment and the zero liquid discharge. So I learned a lot from all the 3 talks. Thank you so much for inviting me and for making me learn all these things. Thank you so much.
Thank you. Moving ahead with the today's program, next we'll be starting the paper presentations. So for these paper presentations, the session chair will be Dr. Joginder Singh from NIT Surat. Welcome, doctor.
Hello.
Yes, sir.
Hello. Yes. You may start, please.
Yes. So I would like to invite Mr. Ketan Janged, Assistant Professor, Department of Chemical Engineering, MBM University, to please continue with the paper presentation session.
Good morning everyone. The next session is technical paper presentation, and in this direction the first presenter is Dr. Prasad TL Gupta, and the title of the paper is Studies on Cell to Tap Based Process Technologies for Brine Management. Dr. Prasad.
Yeah, am I audible?
Yes sir, you are audible. Please continue the presentation.
Yeah. My PPTs are visible, no?
Yes sir. Slides are visible, sir.
Okay.
Yes.
Yeah. Thank you. Good morning, everybody. The topic of my presentation is cell to tap process technologies for brine management. This is supposed to be presented by my colleague Dr. S.T. Maitre. Since he is not available, I am presenting on his behalf. Also, let me thank the organizer for giving this opportunity. So this the layout of my presentation is introduction on commercial desalination techniques and their contributions, need for innovation processes, material methods consisting of selection of strains, experimental setup, then results and discussion, water quality parameters, NDDP, brine conditions and process flow scheme proposed for the same, conclusions. As we know that in commercial desalination, both thermal and membrane based are very well established, and to meet the required water demand continuously, these desalination capacities are increasing. Thermal based, either it can be standalone consisting of LTTT and MED, or co-generation consisting of MSF and MED, and membrane based is RO or integrated membrane systems. So this contribution of various technologies for this meeting the desalination requirement is RO is around distillation is 8% and flash distillation is 33%. So actually, as a economy wise, desalination market is improving, but at the same time, as a researcher and technologist, it is our duty to address the anticipated problematic issues such as brine management, then disposal of membranes, all these things. So to some extent, our BRC is addressing all these issues. So in this talk, I present on what I call biomethods for brine management. So as we know that desalination is very energy intensive, and around thermodynamically 0.7 kilowatt power per meter cube is required, but actual requirement is still higher. And desalination also produces highly concentrated effluent harmful for environment and aquatic life. And recycling of spent membranes is costly and complicated, but needs to be addressed to meet the water requirement through desalination methods. Thus, a need arises a search for energy efficient and green sustainable techniques to achieve this goal. So, biodesalination techniques can be broadly classified as cyanobacteria based, algae plankton based, and microbial fuel cell based. So, these different types of bacteria are commonly employed for purification of municipal and industrial wastewater. But use of bacteria for desalination of saline water has gained significance during recent times. The ability of saline tolerant bacteria to grow at high cell densities with minimal nutritional requirements such as sunlight, carbon dioxide, minerals opens up many future avenues for sustainable water treatment applications. Desalination of effluent such as brine are a valuable resource for producing water required for many other applications such as agriculture and etc. So studies were conducted use of different bacteria for treatment of such water and making it suitable for different applications. As the effluent has high pH, it was decided to utilize bacteria which can tolerate high alkaline conditions along with stability of the bacterial growth and other aspects. Then it was done for an incubation period of 8 days. So it was encouraging trends were noticed. And the water quality parameters for control sample was pH 7.9, TDS 12,600, conductivity 19 microsiemens, density around 1.007. So both after treatment of MED, TVC and SWR with different strains and algae are observed like this, and it was observed that with the pH of both reduced 5 to 7, one large scale reduction is encouraging trends, and almost 5 to 6% reduction is observed. Microbial population has significantly increased, showing the sustainability of the effluent to support the growth of bacteria. The water quality parameters was further improved with more time of incubation. So next, as a part of next phase of trials, we want to do this field studies for our NDDP Kalpakam plant, where we will see different reject streams are being observed, like blow down from MSF consisting of around 187.5 cubic meter and temperature is 40 degree. Other is heat reject some return tank of MSF. Capacity is 1075 cubic meter per hour and temperature 38 degrees centigrade. And excess water for reject dilution is around 1240 cubic meter per hour and temperature 32 degrees centigrade. And RO reject sample is around 140 cubic meter per hour and temperature is 32 degrees centigrade. So this huge quantity of brine needs to be managed to address the issue of pollution aspects and utilization of the large quantity of treated water. So we are planning for some demo scale studies for this RO reject stream having temperature around 32 degrees centigrade. So this basically here I have given the tentative flow diagram consisting of pre-treatment if required, but generally our NDDP we have seen it is not required, and open lagoons for salt-free bio-desalination reservoir, and the preparation of cell culture in bacteria and then mixing with in these lagoons, and filtration and bacteria can be considered for recycling also, and the separated water can be used for the various purposes. So coming to conclusion, the microbial desalination of brine solution offers excellent solution of use of bacteria for making water in useful purpose. Preliminary results of these experiments clearly indicate the role of microbial consortia for reduction of water quality parameters. More efforts is put for isolation and more suitable strain capable of growing under such water can give improved results. Further work on selection of proposed bacteria strain, optimization conditions for this growth and more incubation period can give better results. The characterization and identification of bacteria strain is under progress. Other parameters and use of treated effluent for agriculture is also being done. Thank you. Yeah, thank you. My talk is over. If any questions, I would like to answer.
Is there any question from the participant, from the audience?
No, sir.
Is there any
Okay,
question?
so just one question. Yeah, just one question.
Yeah.
I would like to ask, how did you optimize the condition here in your process?
This is actually phase 1 trials we have done. We are targeting a selection of strains. And for selected strains, then this incubation period and this nutrition requirements we are optimizing. So incubation period, it is what I call we have to establish this high severe conditions of salinity and alkalinity. These strains has to be we have to address. So initial 2-3 stain systems has given a better encouraging results. So trends are encouraging, yeah.
Okay, and what is the repeatability of your results? I mean the experiments?
Yeah, that we have done different incubation period. It is reproducible, and presently 5 to 6% reduction has been observed.
Okay,
And
just
some of the cases, this nitrate content also has been compared to control sample, it has come below detection limits.
Okay, thank you.
Yeah.
Okay, and thank you, sir.
So,
yeah.
On the behalf of the organizing committee, I thank you for this outstanding presentation. Our next presenter is Dr. Ahmed Nawaz, and the title of the paper is Efficient Removal of Chromium 6 using raw and phosphoric acid modify Sterculia alata nutshell. Dr. Ahmed Nawaz.
Hello.
Yes, sir, you are audible. Kindly start the presentation in full screen, sir.
Sir, I am audible.
Yes, sir, you are audible.
Okay, thank you. Good morning to all of you. I am Ahmed Nawaz. I am research scholar from the Department of Chemical Engineering, IIT BHU Varanasi. I am going to present on the topic efficient removal of chromium 6 using raw and phosphoric acid modified Sterculia alata nutshell. Now coming to the introduction part, water pollution as a result of technological development appears to be of great concern. Now we all know that different substance enterprises, for example, copper, zinc, lead, cadmium, chromium, nickel, mercury, alongside wastewater, release a vast sum of water-valuing metals. Chromium is utilized in huge extent in many industrial processes, such as electroplating, colors, tanning, pigments, mesh production, wood production, and alloy manufacturing enterprises. The effluent from various enterprises have plenty full of tri and hexavalent chromium. Chromium is present in aqueous media in two forms as chromate anions and dichromate anions. Hexavalent chromium prevailed in the form of Cr272 minus and SCrO4 minus, CrO4 2 minus, while trivalent prevailed in the form of CrOH4 minus, CrOH2 plus, CrOH3 plus. The toxicity level of hexavalent chromium is 500 times more than the trivalent forms. We know that chromium 6 is acknowledged to be a very lethal contaminant to people, animals as well as plants. Now, researchers have developed different types of chemical and physical techniques to remove chromium 6 from the different industrial effluents such as photocatalysis, electrochemical precipitation, solvent extraction, membrane separation, chemical coagulation, reduction and adsorption for reducing the chrome effluent. The majority of these methods have confinements of high capital and operational expenses as well as issues with the transfer of leftover metal sludge. Now, due to high effectiveness, minimal cost, and simple in operation, the absorption technique remains the most favored technique for the removal of heavy metals. In this study, a comparative study was done in order to eradicate hexavalent chromium from aqueous solution using raw and phosphoric acid modified nutshell. Influence of various parameters such as pH, adsorbent dosage, temperature was investigated. The bioabsorbent was characterized by TGS, EDS, and XRD analysis. Further kinetic and thermodynamic studies were likewise completed. Now, coming to the preparation part of the bioabsorbent, the procured nutshell was obtained and collected from the campus of IIT BHU Varanasi, and it was sun dried for 2 days. The dried biomass was cleaned with double distilled water to eradicate surface dust and impurities. It was then drying in the laboratory muffle furnace at 105 degrees Celsius, and the dehydrated material was powdered and sieved to obtain the desired average particle size of. We have taken mesh in the mesh size of 45 to 50 and kept in the desiccator for further use, and it named as raw RSN, raw sterculia. The phosphoric acid modified has been used for the adsorbent of chromium 6. Then it is first impregnated in the ratio of 2:1, where 2 is the weight of phosphoric acid and 1 is the weight of the adsorbent, and it was immersed in the solution for whole day and was rinsed many times in double distilled water until the pH water of the wash water becomes greater than 6. The material obtained after washing has been dried in the laboratory oven for 105 for 18 hours. Only the acid modified nutshell was put in the desiccator, and it was named PSN, phosphoric acid modified nutshell, in this study. Now the physicochemical characterization part of the raw and chemically treated sterculia lata. The physical chemical characterization you can see from the table that it can be that the moisture content was found to be 7.13 and 5.25 for RSN and PSN respectively. Ash content was found to be 15.36% and 14.15 for RSN respectively. Now the ash content gets reduced after acid treatment due to removal of inorganic salt. Further, the ultimate analysis, which includes CHNS, was found. Carbon was found higher as compared to raw than for PSN. Now the point of ZR PSZPC was found to be 5.07 and 4.89, which shows that bioabsorbents have positive surface charge below their PSZPC. Now, scanning electron microscopy coupled with EDS analysis. Some analysis of the bioabsorbent RSN and PSN prior and later to chromium 6 removal are displayed here. As seen from the figure that the porosity was chemical treatment to raw biomass. Before commence, the surface of the bioabsorbent has rough pores and uneven layers, which was not present after chromium 6 removal, and the surface become smooth as compared to before treatment, before removal. Sorry. Now the EDX results confirm that the carbon carbon and oxygen are the main constituents of the bioabsorbent. However, some inorganic element like silica, calcium, phosphorus, etc. are also present. The ADX analysis revealed that before treatment there was no chromium 6 signal, but after that there was chromium 6 signals as noticed from the EDX analysis. Now, thermal stability analysis of the raw biomass. Thermal stability of the raw biomass was carried out in a thermogravimetric analyzer in the temperature range of ambient to 800 degrees Celsius at heating rate of 10 degrees Celsius per minute under inert condition of nitrogen, and the flow rate was maintained around 100 ml per minute. It can be seen from the figure that the thermogravimetric profile of the raw biomass can be divided into three main degradation stage. The first stage ranges from room temperature to 130 degrees Celsius, which attributes to the removal of moisture. In this stage, weight loss was found to be 6.5% due to inherent moisture retained in the biomass. The second stage, also called the active pyrolysis stage, the temperature in the temperature range of 130 to 418, where weight loss was observed to be 50.28 due to in this state deterioration of cellulose and hemicellulose content of the biomass take place. And the third stage, which is a passive zone, which obtained to be 418 to 800 degrees Celsius, where slow degradation of mass loss to be occurred due to degradation of lignin and complex organic constituents. Now the XRD analysis of the raw and RSN and PSN biomass was executed to understand whether the bioabsorbent has amorphous or crystalline nature. The sharp peak confirms that the substantial amount of crystalline material, where after chemical treatment no appreciable peak change was noted, but increase in peak intensity was noticed. No considerable peak change position denote that the chemical composition of the bioabsorbent has not changed significantly after chemical treatment. The influence of various parameters such as pH and adsorbent dosage and temperature. In this experiment, pH of the solution was varied in between 2 to 12 with initial chromium 6 concentration of 25 milligram per liter was maintained constant, bioabsorbent dose was maintained constant. From the figure it can be seen that the adsorption capacity decreased from 31.2 mg per gram to 13.23 with equilibrium pH changes from 2.03 to 8.91 and for this it is from 28.36 to 12.13 with equilibrium pH changes from 2.02 to 8.98, around 9 for RSN and PSN respectively. This happens because at low pH, chromium 6 ion exists in the most predominant forms such as SCRO4-, which attracted the negatively charged chromium 6 ion because the surface of the PSN and RSN is charged positively. But as the acidic character was decreased, as the pH was decreased, the bioabsorbent nature changes to be negative. Hence, OH- concentration was increased by predominating the CrO42- and Cr2O72-, which causes hindrances in the adsorption process by decreasing the adsorption capacity. Now, influence of adsorbent dosage. In this experiment, RSN and PSN, that is adsorption dosage, was varied in between 0.4 to 3.2 gram per liter. Now, as seen from the figure, that by decreasing the absorption dose, absorption capacity decreased from around 83 mg per gram to 15.6, and for it is for a RSN it is 46.5 to 15.6 mg per gram. This was because large number of active sites of the absorbent has been left over. With increasing dose, as the chromium 6 concentration remains the same, which has been observed already, and also due to accumulation of adsorption particle at higher absorbent doses. Influence of temperature. In this experiment, three temperatures range was selected: 24, 28 and 32 degrees Celsius. The absorption capacity was noticed to be increased from around 29.7 to 54.45 and 51 to 51.7 to 62.1 for RSN and PSN respectively. When temperature was increased, showed that the absorption process here is endothermic in nature. Now the adsorption isotherm study. The most significant information is provided by the adsorption at present, that represents how adsorbed molecules are spread among the solid and
Excuse me, Dr.
liquid
Ahmed, sir. Yeah,
okay.
Actually the time is over, so I request you kindly conclude it.
Okay, thank you. The present work gives the idea of using the agricultural waste RSN and PSN as an effective bioabsorbent to remove chromium 6 from aqueous solution. Further, the same ADS analysis revealed a change in morphological structure and surface irregularities with presence of chromium 6 signals after adsorption of chromium 6. The adsorption of chromium 6 onto PSN follows Langmuir isotherm. While chromium 6 adsorption onto RSN follows Friendlich isotherm. The maximum chromium 6 adsorption capacity obtained was 39.89 and 88.30 milligram for RSN and PSN respectively. Both the adsorption follow pseudo-second order kinetic and was a multi-stage process, means not diffusion control, but it has some film diffusion also. The thermodynamic study suggested that the spontaneous and endothermic nature of the absorption process. These are the references which I have taken. Thank you.
Yeah, is there any question from the participant or the audience?
Yeah, Mr. Ahmed, I would like to ask one or two questions from you. The first one is why you have selected the Striculia alanta, this particular species only for your study. And the second is like when you are going for the phosphoric acid treatment, then your sample shows there is a reduction in oxygen, whereas the phosphoric acid is tend to improve the oxidation effect in the sample. Why it is so?
Because due to removal of some inorganic salts and due to some
inorganic salt, then what is the relationship with the oxygen?
It is the efficiency is 99.99% around at the adsorbent dose, and it is comparable to some of the previous been compared which to some previous studies also, and it is found that it is greater than some activated charcoal also. Biochar, that is, the absorption capacity is more than the biochar. So that's why we.
That is what I am interested in. That how much, by how much percentage it is more. you said that efficiency is almost comparable with the previous method, right?
Yeah.
So don't you think the charcoal itself it is much better in terms of the environmental? I mean better than your technique?
It is, sir, it depends on the type of, we can't say that because it depends on the type of the biomass. Different biomass has different nature. Here we found that it is, the raw biomass is, means you see that it is around the bioabsorption capacity is, absorption capacity is almost half for the for the treated treated biomass. However, as it is published study, as we compared it to I have not shown here the comparison, but I have found from the literature that it is better than some of the biochar which is previously reported.
Okay. Okay, fine. It is over from my side.
Okay,
we
thank
can
you, sir.
move to next presentation, I guess.
Okay, move to the next presenter, Dr. Anushi Rastogi. And the title of the paper is Hydrodynamic Cavitation for the Degradation of Dye from Wastewater, a mini review.
Okay, sure.
Dr. Anushi.
Am I audible, sir?
Yeah, yes, madam, you are audible.
Good morning, everyone. My name is Anushi Rastogi. I am a final year student of Chemical Engineering branch, studying in Meerut Institute of Engineering and Technology. Today, I am going to share a mini review on hydrodynamic cavitation for the degradation of dye from wastewater. The agenda of the PPT would be as follows. Please have a look on it. Textile industry is one of the oldest and complex industry. As the population increased, demand increased. So the discharge of wastewater from textile industry increased proportionally. This wastewater coming out from industry is a major environmental concern as it is laden with different toxic dyes and chemicals. Wastewaters containing such dyes are toxic, mutagenic and carcinogenic to mankind as well as animals. If this wastewater without treatment discharge into the water bodies, then on its usage it can lead to problems like skin irritation, allergic reaction in eyes and respiratory diseases can also be caused. Hence, these toxic dyes need to be treated before discharging or releasing them into the environment. Different methods are also available for that, like adsorption, membrane filtration. But over the past few years, advanced oxidation processes such as phenton, photophenton, cavitation, etc. have come out to be the good for treatment. And among these, hydrodynamic cavitation is one of the emerging technology effective to degrade organic pollutant present in wastewater. So here in the next slide, I will tell you about hydrodynamic cavitation. Hydrodynamic cavitation is basically the formation of cavities due to obstruction in the flow path of water. These cavities can be produced by pressure variation in the flowing liquid, and these cavities are formed at the throat of venturi and orifice. Here in the top right corner, you can see the figure of cavitation device setup, and here in this downstream of this cavitating device, the cavities implode violently, which you can see through this figure in the downwards, where the cavity expands and reaches to its maximum radius and collapses. So this whole phenomena occurs at very high transient temperature and pressure, which results in the oxidation of the water and the radicals like OH radicals, H radicals, and these radicals are produced. Among these, like OH radical is a strong oxidizing agent and it is responsible for degradation of organic matter present in the wastewater. And hydroxyl radicals are powerful oxidants and they are easily generated and they're highly reactive. They are harmless as well. There have been many studies reported in the literature for treatment using hydrodynamic cavitation alone or coupled with other advanced oxidation processes and oxidizing agents. So I have collected a few out of it to study the effect of various operating parameters such as solution pH, inlet pressure and initial concentration on the degradation efficiency of dye. So here in this slide I have I'll be telling you about the effective solution pH, and the solution pH plays a very crucial role in determining the effective decolorization efficiency of dye pollutant. So here in the table we can see that various researchers had different range of solution pH, and the optimum pH was obtained where the decolorization efficiency turns up, and different dye molecules become acidic in nature at conditions, whether it can be acidic or basic, which we can see here. It is somewhat basic and rest is acidic, and here you can see the optimum pH is obtained at basic condition. So this leads to the different decolorization rate. In next slide, see the effect of initial concentration, and various experiments were performed at different ranges, and lower decolorization rate was obtained at higher initial concentration value. For example, here in this blue 13 dye pollutant, the range was taken 30 to 60 ppm, and experiments were performed at different ranges, and here at 30 ppm hydrodynamic cavitation alone gave 47%, but 60 ppm gave only 19%. So this is all due to the insufficient generation of OH radicals to degrade the dye. In the next slide, here we can see the effect of inlet pressure can be seen through various experiments performed by different researchers by varying the inlet pressure using circular venturi, slit venturi and orifice plate. And through this table we can see that through slit venturi at optimum inlet pressure, high decolorization of efficiency can be obtained. Here if we see at blue 13 dye, in the third row, it is being performed at range 3 to 12 bar, and optimum pressure is obtained at 4 bar, where at slit venturi the hydrodynamic cavitation alone gives 47% decolorization, and orifice gives hydrodynamic cavitation alone 31%. So this is all due to the increase in decolorization with increase in inlet pressure, because more cavities are formed at this stage, and more generation of OH radicals occurs. But at a higher inlet pressure beyond optimum, unstable cavities are formed, which reduces the degradation rate of pollutant molecule. And here in this slide, during our study, I found that HC coupled with other advanced oxidation processes gives better decolorization rate, as it increases the number of OH radicals at optimum conditions, and the agents like H2O2, O3 phenton region enhances the decolorization efficiency of dye, as it can be easily dissociated into more reactive OH radicals under the effect of hydrodynamic cavitation. So if we take again the example of reactive blue 13, then experiments were performed at optimum conditions, and it was seen that HC alone gave 47.47% of decolorization, whereas when it's coupled with H2O2 it gave 91%, and when coupled with O3 it gave 100%. So to sum it up my study, I would say that decolorization efficiency totally depends on the nature and the state of the pollutant molecule, which we have seen in the effect of pH slide. And secondly, the decolorization efficiency was also dependent on initial concentration, because initial concentration increased, the degradation rate decreased, and better degradation results can be obtained with the venturi or slit venturi, we can say, as compared to other devices. This is due to the velocity of the liquid in case of slit venturi was higher as compared to circular or orifice, and the pollutant molecule here has the longer exposure to cavitation conditions, which leads to higher decolorization. So overall, based on the literature, I would say combined strategy of hydrodynamic cavitation with other advanced oxidation processes and oxidizing agents like H2O2, penton region, and ozone has found to be effective in treating the dye wastewater, and hence it can be a better option for the treatment of industrial wastewater. So here are the references from where I have taken. Thank you. I would like to thank the organizing committee for giving me this opportunity. Thank you.
Yeah, is there any question from the audience? From the participant?
Yeah, I want to ask one question. Yeah, Ms. Rastogi, that what is the magnitude of these experiments which these all scholars have studied actually? The magnitude at which these studies were carried out? Mention what volume they have carried out, like 1 liter, 2 liter, 5 liter.
Okay, sir. Sir, they were like different for different papers, like some what have taken to up to 5 liters and some what have taken to up to 30 liters as well. So it totally was dependent on different papers have taken different volume for the paper.
Good afternoon, everyone. I hope audio and video are clear. So let me begin by thanking the organizers for giving me the opportunity to present my work on simultaneous removal of cationic dyes from aqueous solution in a binary system using rhamnolipid-based micellar enhanced ultrafiltration. I am elated to present this work on behalf of myself, Ms. Kashish, Dr. Deepak, and Dr. Biswajit sir. I am a final year student in master's program in chemical engineering from Guru Gobind Singh Indraprasth University. So moving on to the flow of the presentation, I will first give about micellar enhanced ultrafiltration, then biosurfactants, then the objectives of this study, the methodology, the process optimization performed, the results and the conclusion and the future scope of this work. On the right hand side table, I have listed a few abbreviations which will be helpful keeping in mind our work. As Ms. Anushi has already given us the effects of textile dye-based wastewater, harmful effect of textile dye-based wastewater, I don't think I have to elaborate on that. So moving on, I propose the solution of micellar enhanced ultrafiltration. So this has emerged as a promising technique for removal of low concentration levels of waste from industrial pollutants. My work is based on the adsorption of dyes into large surfactant micelles, from where when the surfactant is added in an aqueous polluted stream above its critical micellar concentration. This followed by ultrafiltration by an appropriate membrane rejects the micelle associated with pollutants into the retented stream. The basic advantage of micellar enhanced ultrafiltration and the reason for choosing this work is that it can be performed in ambient environmental conditions, saving us the energy cost over alternative separations, as well as comparable separations such as reverse osmosis and nanofiltration require high pressures or membranes which are very costly as well as prone to fouling, which is a problem which will not be encountered in micellar enhanced ultrafiltration. So here I have given the schematics of the process, such as the free ionic solute present and the surfactant micelle, which when bound with the solute then can be filtered by the ultrafiltration membrane. So why I chose biosurfactant? First of all, biosurfactants. Biosurfactants are surface active biomolecules produced by microbes. They have a wide range of application and have gained a lot of interest in recent years owing to their unique properties. specificity, low toxicity, and relative ease of preparations, and have found extensive use in petrochemical industry, pharmaceutical, textiles, and cosmetics-based industry. My reason for choosing biosurfactant over chemical-based surfactants are they're highly efficient, they are low toxic, they have very low toxicity, they are biodegradable, and most important, they have ecological acceptability in our community. So the objectives of my study are obtaining the adsorption isotherm for crystal violet and methylene blue dyes onto the RHL vesicles in a single and binary dye system, and optimization of heat condition for obtaining the removal efficiency, maximum removal efficiency of both these dyes simultaneously. So the methodology of my work was, first I performed membrane compaction using a 10 kDa flat sheet membrane, following which standard dye solutions were calibrated in the spectrophotometer at 664 nanometer for methylene blue and 589 nanometer crystal violet. After which I prepared 200 ml single dye systems at varying process conditions and fed them into a batch membrane at 150 ml while retaining 50 ml as feed, performing batch runs at a constant rate to obtain the adsorption isotherm. All these adsorption isotherms were performed at ambient room temperature as well as the transfer pressure at 30 psi for all these experiments. The following which I obtained the adsorption isotherm and optimization enhanced ultrafiltration was performed at 40 psi with a stirrer speed of 600 rpm, and experimental flux decline with time data was collected. After which I tested the both samples to determine their concentration, and the membrane was given an acid bath in 1 normal HCl for 15 minutes, followed by washing to determine its reusability. So here I have listed the operating conditions, that is pressure between 30 and 40 psi, the stirring speed at 600 rpm. The dye concentration, it was between 10 to 45 ppm for single dye system, methylene blue 5 to 30 ppm for single dye system, whereas for the binary system it was between 6.6 to 23 and 3.3 to 11.7 respectively. The rhamnolipid concentration ranged between 330 to 1170 ppm, whereas the sodium chloride concentration was 10 grams per liter. So here I have listed the adsorption capacity versus concentration graphs. On the top hand we have both graphs for crystal violet, and on the bottom side we have for methylene blue. The left hand side graphs, top and bottom, show for single component, and on the right hand side we have graphs for binary system. Approximately 15-16 experiments of 2 hours run were performed so as to get the adsorption isotherm data. So here I have given the adsorption isotherm table, wherein I fitted the data and into the 3 most well-known equations, that is the Langmuir, Freundlich and the Temkin adsorption isotherm. I have given various parameters such as scale, maximum adsorption capacity, R square, and delta G, and all other values. We found that Langmuir adsorption isotherm was Langmuir adsorption isotherm represented both the single as well as the binary dye system very well. After which I performed the process optimization to determine the mathematical relationship between the responses and factors to arrive at an optimal conditions for our experiment. The results were performed in a response surface methodology using design expert, which are as follows. Here x1 gives the concentration of crystal violet, x2 is the concentration of methylene blue, while x3 is the concentration of rhamnolipid. Y1 is the concentration of Y1 is the removal efficiency of crystal violet in percentage. Y2 is the removal efficiency of methylene. Y3 gives the average permeate flux. We aim to maximize all 3 parameters simultaneously. Moving on, following the 20 experiments I performed here. A stepwise regression was performed using ANOVA, and the validity of empirical model was tested using ANOVA at 95% confidence level. Here Y1 is the removal efficiency of CV, Y2 is the removal efficiency of MB, and Y3 gives the average permeate flux. So the optimal condition I obtained were as follows. The crystal violet concentration was 11.3 ppm, methylene blue concentration was 7.2 ppm, and the rhamnolipid concentration was 880 milligrams per liter. For this, we obtained a removal efficiency of 96% for crystal violet, for methylene blue 94%, and the flux was approximately 6.3 liter per meter square per hour with a desirability of 0.967. Using these optimal conditions, we performed an confirmatory experiments to check whether the data, the statistical data, conforms with the our real world experiment. So we found to the that it was in agreement that our experimental data was in agreement with our statistical analysis. That is, we got a removal, crystal violet removal for 95%, methylene blue removal of 93%, and an average permeate flux of 5.9 liter per meter square per hour. So here I have given the permeate flux graph wherein the operation time was 2 hours and the permeate flux obtained was 5.59 liter per meter square per hour. Here I have shown the removal, in these three graphs I have shown the most important parameters affecting our removal efficiency. In the first graph I have shown the removal efficiency as a function of feed dye concentration and biosurfactant concentration. On the right hand side I have shown removal efficiency of methylene blue as a function of feed dye concentration, that is crystal violet, and biosurfactant concentration. In the bottom graph I have shown the permeate flux as a function of feed dye concentration, and as we can see in the first graph on the left hand side, the removal efficiency of crystal violet is a strong function of methylene blue as well as the rhamnolipid concentration, wherein increasing the rhamnolipid concentration, it increases to a certain point after which it plateaus. Similarly, as we increase the concentration of methylene blue, we observe the similar effect. Whereas as we increase the concentration of feed dye in methylene blue as well as crystal violet, the average permeate flux declines. So here is my experimental setup, and in this figure I have shown the I am showing the optimal conditions wherein I have taken crystal violet 11.2 ppm, methylene blue 7.2 ppm, and after mixing I obtained this this solution which containing the optimal concentration, following which MUF process was performed and obtained a colorless solution as shown on the right hand side. This was my membrane after use, and on the right hand side I have shown the membrane after washing. So what conclusions I derived from this experimentation? The work showed me that adsorption isotherm analysis was performed very well, and I reached the conclusion that Lagomir isotherm served better to represent the isotherm of individual as well as the binary dye, and also the decline in the maximum infiltration was successfully applied and the process parameters were optimized and maximum removal efficiency was obtained. Also, we found that the removal efficiency and permeate flux are a strong function of feed dye concentration and the surfactant concentration. Based on this, we can scale up the MUF for use in cross-flow filtration mode as well as enhance the solute complexity to include other parameters as well. So, thank you. Thank you. I would like to thank the presenters, organizers for giving me a chance to present my work. Any questions?
Yeah, Mr. Pandey, there is one question.
Yes, sir.
Yeah, like,
yes, sir.
Yeah, as you discussed that you use your ultrafiltration membrane of 10 kDa for filtration of using this your dye filtration. Okay, so generally ultrafiltration membrane works on the size exclusion principle. So if the molecule which is lesser than adsorption, so there is a clear-cut distinction between accumulation and adsorption. Are you sure it is adsorption?
Sir, adsorption was occurring. Although accumulation of dye was also there, but adsorption is occurring in the system.
Okay, Dr. Shivam, I also want to ask one question. You got some optimized data from using Design Expert software, right?
Yes, sir.
Have you validated those data?
Yes, sir. I performed duplication.
Can you show the results?
And the confirmatory
means what was the means validation results
sir,
I am asking for.
Sir, the optimal conditions that I obtained, I performed a confirmatory experiment for the given optimal condition. That is the 11.7 ppm crystal wallet, 7.2 ppm dye, and found the experimental result to be in sync with our statistical design.
So, what error you got in?
Sorry, sir?
Means, did you get any error in the validation data and the optimized data?
Sir, error, I think just sir, there was 0.2% 0.2% error in crystal wallet and removal, and 0.5% in methylene blue removal.
It means you got very good results. Okay.
Yes, sir. Yes,
okay.
sir. Yes, sir.
Thank you, Dr. Shivam Pandey. Now move to the next presenter. Our next presenter is S. Elakia, and the title of the paper is Hybrid Membranes Tailored with Haloside Polyaniline for Efficient Removal of Carcinogenic Disinfection Byproducts Precursor from Water.
Good afternoon to all. I am audible.
Yeah, you are audible. Please continue.
Hello. Hello.
Yes, Dr. Elakia, you are audible. Please continue the presentation.
Hello. I am audible.
Yeah, you are audible. Please continue.
I am under Dr. G. Ardhanareshwaran, sir. Okay, sir. Thank you, sir. My title is Hybrid Membrane Tailored with Haloside Polyaniline for Efficient Removal of Carcinogenic Disinfection Byproduct Precursor from Water. Introduction. Clean water is a vital source for all life on Earth. Nowadays, the increased natural organic content concentration entering water provision via the decomposition of plant and animal residues during its natural cycle cause an environment human present in water. It acts as a chromogenic substance that appears as dark brown color in groundwater and surface water. Humic acid itself is not toxic, but it plays a vital role while in during disinfection. During disinfection, it will react with the chlorine and it will cause carcinogenic byproducts. So its removal is important for society. Humic acid contamination in water. Water contaminated with humic acid shows undesirable odor, taste, color, and associated things. During decomposition of plants, the humic acid is removed to the surface water, and during agricultural runoff, the fertilizer used from the plants growing also increase the contamination. And these are the health hazard due to the reaction of humic acid with the chlorine substance during disinfection. It causes a disinfection byproduct which is carcinogenic and mutagenic. Membrane technology for water treatment, that is treatment technology. Various treatment technologies are available for the removal of humic acid, that is coagulation, advanced oxidation, adsorption, and membrane technology. These technology has several disadvantages such as large energy requiring, slow process, low removal rate, low cost effectiveness, and usage of more chemicals. Among various technology, membrane technology has got more attention owing to its simple operation, high efficiency, environmental friendly, and less energy consumption. The rejection mechanism is two types of mechanism. One is size exclusion. It is based on the humic acid size and the membrane pore size. And the Donan exclusion is based on the charge of the humic acid and the charge of the membrane. Properties of hybrid membrane. Instead of using pristine membrane for humic acid removal, I have gone for hybrid membrane fabrication and use those hybrid membrane for humic acid removal. The humic acid deposition inside the membrane, that is pristine membrane, will cause diminution of flux, diminish the membrane performance. So I have preferred hybrid membrane. Hybrid membrane is the blending of hydrophilic functionalized nanoparticle with the polymer that improve the permeability, removal efficiency, hydrophilicity, morphology, and antifouling property of the lifespan. So I have used a hybrid membrane for my research. I have selected halloysite nanotube for making the hybrid membrane, that is low cost environmental friendly nanoclay. It is nanotubular aluminous silicate mineral that have immense attention for hybrid membrane fabrication. It has a hydroxyl group and negatively charged crystal structure helps for improve the hydrophilicity and other membrane properties. So I have selected halloysite nanotube. After selecting, I have functionalized those halloysite with using polyaniline because functionalization will bestow with novel properties. Polyaniline is aromatic ring connected via nitrogen containing group. So I have selected polyaniline that increase the hydrophilicity and it also low cost non-toxicity. So I have selected polyaniline for functionalization of halloysite. Using anilium chloride and ammonium persulfate, I have converted that halloysite into halloysite polyaniline. The main research gap and motivation is large amount of attention was given for innovative membrane. Humic acid removal is needed for our society, and even in membrane technology there is a trade-off between permeability and activity during filtration process. So I have ventilated structure, functionalized the halloysite polyaniline within the hybrid membrane, tuned the transport pathway membrane performance. And objective synthesis of halloysite polyaniline, fabricating the hybrid membrane and characterization. I have evaluated the filtration performance with using the humic acid and found out the antifouling property of the prepared hybrid membrane. And this is a fabrication of hybrid membrane. I have mixed the halloysite nanoparticle, polyaniline nanoparticle within the casting solution, that is dope solution, with the NMP and polyether sulfone. I have, after making the homogeneous solution, I casted on a clean glass plate, and coagulation bath is set at 10 degrees Celsius. With the 30 seconds of evaporation time, I have fabricated the membrane using phase inversion technique. I have varied the composition of the polymer and halloysite, that is halloysite polyaniline, from 0.5 to 2%. This is the evaluation setup of pure water flux and removal efficiency of humic acid. Dead-end filtration I have used. And resultant discussion characterization of haloside polyaniline. The FTR result confirmed that the presence of benzoid and quinoid of polyaniline and haloside group within the haloside polyaniline. The HRD peak also, the main peak also resembled that haloside confirmed the functional haloside that flux of the hybrid membrane. The surface roughness resembles the higher surface roughness of lead membrane confirm that hydrophobic and it impart the was from the and fouling and irreversible fouling also I have studied that resemble that the flux recovery ratio for hybrid membrane is higher, which resemble the higher original flux retaining ratio, and the flux decline ratio for hybrid membrane is lower. That confirm that it can be easily retain the original flux. While the neat membrane shown low flux recovery ratio because due to the accumulation of humic acid inside the pores have blocked the membrane pores so that the flux recovery ratio is reduced. And while comparing the fouling properties of the Y0 membrane, that is neat membrane with the hybrid membrane, the hybrid membrane shown higher anti-fouling property because due to the presence of halosite polyaniline within the structure that impart more hydration layer over the surface so that there is a weak accumulation between the membrane and the humic acid. The interaction is less compared to the Y0 membrane. I have compared the result of my hybrid membrane with various other membrane. So I found out that the flux recovery ratio of my membrane is higher due to the presence of halosite and polyaniline, and the removal efficiency also higher. I have selected 100 ppm for as feed concentration, while comparing with other membrane like graphene oxide, polyethylene glycol, and zinc sulfide. Compared to other nanoparticle, the HNTU polyaniline shown higher result. Conclusion: I have fabricated the halosite polyaniline hybrid membrane. The existence of halosite polyaniline hybrid membrane altered the membrane properties. The functional group amine and hydroxyl group within the hybrid membrane improved the hydrophilicity. 1 weight percentage halosite polyaniline tailored hybrid membrane revealed higher humic acid removal of 91% with higher flux recovery ratio and low flux decline ratio. The electrostatic repulsion between the humic acid and hybrid membrane improved the humic acid removal efficiency. The hydrogen bonding between water molecule and hybrid membrane facilitated high flux recovery ratio, high reversible fouling, and low total fouling. The wettability property of halosite polyaniline tailored hybrid membrane revealed higher humic acid removal and improved the anti-fouling property that rendered its application for water treatment. Acknowledgement: I express my deepest gratitude to God and my family members. I thank my research guide, Dr. G. Adnareshan sir. I thank Royal Academy of Engineering, United Kingdom for partial financial. Grateful to my research lab group members. With immense pleasure, I would like to take this opportunity to thank organizing committee members, Desalination of Water Treatment, Recent Technological Advancement Challenge and Opportunities, and Annual Congress of InDACON 2022. Selected reference, and thank you.
Okay, and thank you, madam. Is there any question from the participant audience?
Thank you.
Technology for water recovery, desalination, and resource recovery. So for membrane distillation to be a standalone technology, the membrane used must also should exhibit a good thermal stability, chemical resistance, high permeability, low resistance to mass transfer, high hydrophobicity, and narrow pore size distribution, which are all the characteristics of electrospin membrane. Of my study develop electrospin nanofibrous membrane with enhanced hydrophobicity and to evaluate those prepared electrospin nanofibrous membrane for the application of seawater desalination. Also, the scope of my study includes the promoting sustainability with the potential to utilize renewable energy for membrane distillation, reduce the consumption of fresh water, promotes recycling resources, promote resource recovery, which is the need of the hour, and also decentralized options. So this slide shows the schematic of materials and methodology. The silica-based mesoporous nanoparticles were surface functionalized with perfluorodecyl triethoxysilane, and it was named surface functionalized or modified silica nanoparticle. The electrospinning conditions were maintained at a flow rate of 1.7 ml per hour and potential difference of 20 kilovolt, tip to collector distance of 15 centimeter, and the drum speed of 1300 RPM. So to prepare membranes with enhanced hydrophobicity, first the pristine PVDF co-HFP electrospin and fibrous membrane was fabricated, on which the silica nanoparticle incorporated electrospun nanofibers were fabricated, and these two both layers were pressed together to form a dual layer hydrophobic membrane with graded hydrophobicity. So one of those membranes were coated with the same perfluorodecyl triethoxysilane, and both uncoated and surface coated membranes were evaluated for their performance in DCMD application for salt rejection and direct seawater desalination. So this slide shows the particle characteristics. So the low angle XRD plane at 100 revealed the presence of disordered hexagonal pore arrays. The FTR spectra revealed the asymmetric SIO, SI stretching, SIO bond bending, SIO stretching, and CF stretching, which CF stretching corresponds to the surface functionalized group. And the same image represents the surface functionalized silica-based nanoparticle. So wherein the agglomerated nanospherical morphology and irregularity was attributed to the unfavorable packing or collapse of the spherical micelles. Also, the presence of silica and oxygen corresponding to the silica nanoparticle and fluorine that it's corresponding to the surface functionalization is evident from the elemental composition. This slide presents the results or the characterization of the electrospun nanofibers. So MSI represents the uncoated membrane and MSIC represents the coated membrane. So the thickness is very close to 125 micrometer, and porosity on an average it is around 75 percentage. The water contact angle increased from 136 to 142 degree upon surface coating with PFDTES. So it depicts an increase in hydrophobicity. And also the FTIR findings reveal the antisymmetric stretching of CF2 groups and out of plane deformation of CF3 bonds at 1400 wave number. So which is a characteristic of the PVDF quartz FP polymer. Also the same image reveals the formation of the beadless fibers. So the increase in diameter and the surface roughness can be observed in the fibers upon incorporation of the silica-based nanoparticles. So the elemental analysis also revealed the presence of silica of 0.39 percentage. So this is denoting the successful incorporation of the silica nanoparticles in the electrospun nanofibers. So this is the water contact angle depicting a degree of 136 and 142 upon surface coating. So this slide presents the flux and rejection of coated and uncoated membrane for salt rejections with NaCl. So DCMT experimental runs were initially conducted with 10,000 ppm NaCl, 25,000 and 35,000 NaCl feed solutions. The effect of flow rates such as 15, 20, 25 LPH were studied, and it can be inferred from the graphs or the three graphs like the rejection was always greater than 99.9% and the flux values were improving upon the surface coating of the membrane, which increased the surface hydrophobicity. So from these studies, we took an optimum flow rate of 20 LPH, and the membrane, coated membrane MSIC was used for direct seawater desalination. So the flux and rejection of seawater desalination is present here. So it can be seen that a stable north-east flux was observed for intermittent 6-hour runs as 3 cycles. So the feed and permeate flow rate was maintained at 20 LPH, and the feed conductivity was found to be 53,480 microsiemens per centimeter, and the permeate conductivity remained to be less than 50 microsiemens per centimeter all throughout the 3 cycles. And this particular bar graph, it represents the water contact angle of the fresh MSIC, that is the coated membrane, and MSIC after the seawater membrane distillation, and after simple washing with water. So with simple washing, water contact angle can be lowered, and therefore the hydrophobicity of the membrane. It doesn't require any chemical washing or so. And also, this is also like evident from the SEM images. So MSI is the SEM image of this is the same image of MSI, wherein we can see the scaling of or the growth of crystals on the nanofibrous membranes. Whereas this is a MSIC, that is coated membrane with PFDTs. There was no scaling observed in this membrane, so which we can say like the membrane is having an anti-scaling property. So therefore, from this study, it can be inferred that electrospun nanofiber membrane with surface modification has the abundant potential for DCMD application, for seawater desalination, as well as for high water quality recovery, as well as we are also trying on working on removal of persisting organic compounds. So I thank the conference organizers for giving me this opportunity to present my work. These are some of the selected references we used for the study. Thank you everyone.
Okay, thank you, madam. Is there any question from the audience? Okay, on the behalf of the committee, I thank you, madam, for the presentation. Our
Thank you.
Next presenter is Dr. Jenny Nambikattu, and the title of the paper is Iron Oxyhydroxide Impregnated PVDF HFP Membranes for Propylene Glycol Concentration and Seawater Desalination via Direct Contact Membranes Distillation. It seems she is not connected to us. So we move to the next presenter. Our next presenter is Dr. Shivali Sen, and the title of the paper is Assessment of the Chambal River Water Quality at Kota Metropolis through the Drinking Water Quality Index from 2018 to 2021.
Dear sir, this paper is presented by Aparna Sharma, not Shivali Sen. She is a co-author of this paper.
Okay. So the presenter is Dr. Aparna Sharma. Yeah. I want to mention here the presentation time is 10 minutes. So kindly complete.
Respected.
Yeah. Yes, madam.
Am
please
I
continue.
audible, sir?
Yeah, madam, you are audible. Please continue.
Good afternoon, respected faculty members and students. Myself, Aparna Sharma, MTech student in Environment Engineering of Civil Department in Rajasthan Technical University, Kota. Today, I am here to represent my research paper on assessment of Chambal River water quality at Kota Metropolitan through the Drinking Water Quality Index from 2017 to 2021. Thank you so much for providing me a wonderful opportunity to present my research paper. So let's start with brief introduction regarding to water pollution. As we know that water pollution is a widespread problem, poses a great threat to human health and environment. Globally, around 80% of wastewater is dumped back into the environment, polluting natural water bodies such as the lake, river, and ocean. Worldwide, it was reported that at least 2 billion people use contaminated drinking water sources. Contaminated water can transmit diseases such as diarrhea, cholera, dysentery, typhoid, polio, and it is estimated to cause 485,000 diarrheal deaths each year. Water is an essential compound required for the survival of all forms of life, hence enlisted in Sustainable Development Goals. Source of water pollution. Source of water pollution are divided in two types: point sources, non-point sources. Point sources include wastewater influent from municipal and industrial unit, while non-point sources included urban runoff, unsewered and sewered areas with a population is less than 1 lakh. Point sources sites are greater than 2 hectares, such as the runoff from waste disposal sites, animal feedlots, mines, for oil fields, unsewered industrial site and construction sites, while urban runoff from agriculture, pasture and range, construction sites, above mines and atmospheric disposal over a water surface are come under the category of non-point sources. Storm sewer outflow from cities with a population is greater than 1 lakh are fall under the category of point sources, while septic tank leachant and runoff from fields septic system are fall under the category of non-point sources. Overflow of combined storm and sanitary sewers are classified in point sources, while activities on land that generate contaminants such as logging, wetland conversion, construction and development of land or waterways are classified in non-point sources. Objective. Objective of this study are shown in this slide. At the first, we see to stabilize baseline information both in trend and concentration for Chambal River following through the Kota metropolitan, to define suitability of river water for drinking purpose from 2017 to 2021. Third is to determine the pollution sources if the pollutant are detected. Fourth is to recommend the remedial actions. Research methodology. Research methodology adopted of this study are shown in this slide. At the first, the problem identification, source, causes, impact and mitigation. Literature survey. Objective and scope of research, data observation, observation period, define water quality for drinking, research and discussion, and conclusion. Study area and the sampling point. Chambal River passes through the Kota city, which is the most crucial resources for fulfilling the countless purposes of millions of cities of the towns, including drinking water, irrigation, domestic use, industrial use, environmental activity, etc. For sampling point at upstream and the downstream of Kota barrage of the Chambal River were selected for study is Akelgarh, Rampura, Sri Rajeshwar Temple and Kesharai Patan. The testing of the samples were performed in the laboratory of the regional office and the Rajasthan State Pollution Control Board Kota. Total sample is 217. In this slide, we see the distribution of each sampling point for each year shown in this slide. Data observation. The observation period is 1st January 2017 to 31st December 2021. Total number of parameters are 23, such as ammonia nitrate, BOD, boron, COD, calcium chloride, conductivity, dissolved oxygen, fecal coliform, fluoride, magnesium, nitrate, pH, potassium, sodium, sulfate, temperature, bicarbonate, total coliform, total dissolved solid, total hardness, and turbidity. Seasonal breakdown of observation period. Winter is January, February, November, December. Summer is March, April, May, June, and rainy season is September, October. The water quality index. Water quality index for each parameter are shown in this slide. The measurement of the water quality calculation are shown in this slide. At the first, we are calculated the relative weight, and then we calculate the quality rating scale and the sub index, and the summation of the sum index give us the value of the water quality index. The classification of the water quality index are shown in this slide. The classification of the water quality index are divided in 5 types. That is 0 to 50 is excellent, 50 to 100 is good, 100 to 200 is poor, 200 to 300 is very poor, 300 to 400 is unsuitable. The calculation of calculate water quality index value for Akelgarh, Rangpura, Sri Rajeshwar Temple and the Kesharai pattern are mentioned here. The water quality is gradually increasing from 2000 gradually increasing from 2017 to 2021. The maximum water quality was 2017 and the maximum water quality in 2021 from each location. The water quality index was maximum in summer session, followed by winter session and rainy session for every location except for Keshurai Patan, where the water quality index is maximum in compared rainy session compared to the winter session. The increasing term of water quality index for each location is presented in this slide. The water quality index for Akelgat is lies in the range of 50 to 100, which means the water quality for drinking purpose is good. While the water quality index for Rangpura and Shri Raj Rajeshwar temple is lies between 100 to 300. Water quality at this sampling point varies from poor to very poor category. The river water at their point can't be advised for as a drinking purpose. The river water quality worst in Keshurai Patan, as the water quality index lies in between 200 to 300, should be provisional to use this water. This water can't be used as a drinking purpose without any treatment process. Conclusion: the water quality index values at upstream and downstream of Chambal River Dam at Kota city shown a great variation in water quality parameter. Water quality at upstream of Kota Beraj Akelgat is good due to the absence of pollutant sources. The river water can be used to satisfy drinking water quality demand. Water quality at downstream of Kota Beraj, Rangpura, Shri Rajeshwar Temple, Keshurai Patan is poor to very poor due to discharge of more than 2 dozen wastewater stream should be west side agriculture and surface runoff and industrial waste. Rapid urbanization, pollution growth, improver town planning, outdated sewage system, discharge of wastewater stream directly into river, agriculture runoff, surface runoff and unawareness. The river water in the downstream of the Kota city is unsuitable to drinking water without any treatment. Remedial action and future scope. Remedial action: public awareness should be created and wastewater stream should be treated before discharge into the river to decrease the river water contaminant load. The present study may be used as baseline information both in concentration and trained by the regulating authorities. Heavy metal and the radioactive material can be included in monitoring parameter for future study and on the Chambal River and the other river. Thank you so much, sir. Any queries, please?
Thank you, madam. On the behalf of the organizing committee, I thank you for your insightful presentation. Is there any question from the participant or our audience?
Yes, one question.
Yes, sir.
Hello.
Please ask.
Yes,
How to measure water quality index?
At the first, we are assign a weight and then we are calculate the relative weight and the quality rating index, and after this we are calculate sub-index, and the summation of sub-index given us the value of the water quality index.
So, okay, you gave it in terms of weight. So, can you tell me more? So, in weight, what are the different constituents or different parameters they are already included in the weight? Because you
properties, it's
yes.
Completely depend on the property of the climate.
The climate is different thing because you have included the weight in your formula, na, water quality index.
Yes,
so mean
sir.
to say, if weight is vary, suppose it is high, it is low,
Yes,
then
sir.
what the different content it have, so that the weight is variable. I'm asking that one.
Let me answer this question, sir. I am co-author of this paper. The weight is assigned on the basis of the property of parameter. Maximum weight is assigned is 5 and the less weight is 0 to 5.
Listen, that is okay that you assign the value from 0 to 5, but I'm
Yes, sir.
asking the weight is vary from 0 to 5, but what are the reason? What is the reason behind the variance in the weight?
So
What
this
are the
depend on
different parameters
the
which contributed towards the weight?
so this is the impact of parameter on the water quality, such as nitrate has a very detrimental to human health, and BOD, CODs. So these are the gain the maximum weight of approximately 5, and such as calcium, magnesium, we get to very lesser weight, such as 2, 3, and 4, depending upon the impact of the parameter.
Okay, this is the one way of measuring the water quality index.
Sir, this is the Indian way to measure because we have do very much literature survey in Indian scenario, and we get this method to obtain water quality method in India.
Okay. Okay, thank you. Thank you.
Okay, thank you, madam. Now next, move to the next presenter. Our next presenter is Dr. Vinod Kumar Meena, and the title of the paper is Current Voltage Relationships in Electrochemical Advanced Oxidation of Lamotrigine in Wastewater. Dr. Vinod Kumar Meena. Sir, please continue.
Okay. Okay, thank you very much for giving me the opportunity. And so am I audible or my slides are there?
You are audible, but slides are not visible.
Okay, okay, okay. Now?
Yeah, now slides are visible.
Okay, okay, okay. Thank you.
Sir, it is requested, please open the slides in full screen, sir.
Okay, okay. So I think it is not working. So how to zoom it exactly? Because one minute. How to zoom it? Can you help me out? Is there any option on the window so that I could zoom it?
Sir, press F5.
Okay, okay. Thank you. No, I think I have pressed 5, but it is not working. Control plus F5?
No, sir, only F5 key.
Okay, only F5 key. So I have pressed F5 also, but it is not working at all.
Sir, please go to the slideshow menu at the top. There you will have the option to run slideshow.
Okay. There is one option is
slideshow at the top menu, sir. Near animations.
Near animations, is there any slideshow? No, actually, your screen is there where there are 3 options. One is show active speaker and turn whale video, then show grid view, and show active speaker video.
Actually, sir, I'll ask the our operator to send you a remote control request. Please accept that request.
Okay.
We'll do the presentation.
Okay. Yes, yes. Now approve. I have approved that. is it working? Okay. Okay. Now it is visible to all?
Yes, yes.
Okay. So thank you very much for giving me the opportunity. And it gives me immense pleasure also to be the part of this conference, being an alumni of the Institute and Chemical Engineering. So my topic is as current voltage relationships in electrochemical advanced oxidation of lamotrigine in wastewater, and my co-author is Himadri Roy Ghatak, professor with the department. I'm working here as an assistant professor in Sant Longwal Institute of Engineering and Technology, Longwal, Punjab itself. Then in the introductory portion, lamotrigine is a new generation classified anti-epileptic drug that is used for the basically for the seizure treatment in patients. A recent study comprises that 94% of the samples in which they are affected by the wastewater with the lamotrigine at an average concentration of 488 nanogram per liter. And other than the harmful effect of the lamotrigines are fever, headache, fatigue, and diarrhea. And there is a persistent presence of LAM in environmental samples indicated its remarkable stability in conventional water treatment processes in the environment. Moreover, it is quite resistant to advanced treatment like photolysis and ozonation. That is why it is generally it is called EP, the emerging pollutant also. And this study also report the current voltage relationship of lamotrigine using the process of electrooxidation on TIDSA and combined electrooxidation and electrocoagulation on SSA node. The effect of different process parameters is studied. The two different processes are compared for their cell voltage requirement also. Then the materials and different methods which are used in the study are lamotrigine, that is of pharmaceutical grade, that is used as target organic pollutant. Then the two different types of anodes like TIDSA and SS304 were used in the study. Anhydrous sodium sulfate and the millibore water was used in the study for experimentation. Then the electrochemical experiments, all the experiments of the lamotrigine were performed in a glass reactor of 250 ml in conjunction with computer controlled potentiostat galvanostat model SP150 with EC lab. Then TIDSA as the anode and SS304 or the cathode were used for the process. Now we come to the result and discussion portion. So basically this is the effect of current density over time on the voltage for the electrooxidation of lamotrigine on TIDSA anode. And if you see the window, then there is clearly the relation between voltage and time. So as we increase the current density from 1.11 to 1.31, then there is an increase in voltage 7.74 volt to 8.98 voltage. And with the further increase in the current density, the voltage is down from 7.92 volt. So the electrooxidation will be carried out at increased potentials as shown in the figure, but value of soil voltage during process was observed decreasing from 8.98 volt approx to 7.9 volt as current density increased from 1.38 to 1.58 milliampere per centimeter square. Basically, there are three current densities we have studied. So the reason for the increase or for the decrease of voltage from second to third is there is a larger amount of gas production. So similarly, the second figure shows you the effect of supporting electrolyte concentration over time on the voltage for electrooxidation of lamotrigine. So there is a continuous decrement in the voltage value because the reason behind this is higher the Na2SO4 concentration, lower the cell voltage required to maintain a given current density. So this is for the electrooxidation of lamotrigine. Now we come to the electrooxidation and electrocoagulation of lamotrigine. Then again there is this graph shows you the effect of current density over time on voltage for the combined electrooxidation and electrocoagulation, and there is a continuous increment from the voltage approx from 7.84 voltage to 8. 0.48 volt, then it goes up to 9.44 volt. Then if we see the effect of supporting electrolyte concentration over time on voltage for the combined electrooxidation and electrocoagulation of lamotrigine over SS, that is stainless steel. Then again there is a first the voltage is slightly increased from 8.4 volt to 8.8 volt because there is a increment in also the mineralization value. That is, it can be from almost 61 to 72%. Then there is a decrement as per the previous region because there is a, if higher the supporting electrolyte concentration, there is a lower cell voltage requirement. So this is about the behavior of current voltage or the relationship of current voltage during the electrooxidation experiment and the combined electrooxidation and electrocoagulation experiment. The current voltage relationship during electrooxidation and the combined electrooxidation and electrocoagulation of an anti-epileptic drug, lamotrigine, over the time depended on the anode types. It is very well depicted. In electrooxidation operation on lamotrigine carried out on TIDS anode, maximum cell potential of 8.98 volt was achieved, whereas in combined electrooxidation and electrocoagulation on lamotrigine SS on SS anode, maximum cell voltage of 9.44 volt was achieved. In the combined process on stainless steel anode required improved cell voltage than electrooxidation on TIDSA reflected in the current voltage relationships in the two processes. And to present this, the references which are used, they are the references, or the few references out of this study. And thank you very much.
Okay, thank you, sir. On the behalf of the committee, I thank you for your insightful presentation. Is there any question from the audience? Okay, sir, it seems there is no question. So we move to the next presenter. Our next presenter is Dr. Mahendra Singh. Yeah, and the title of the paper is Recent Advances and Challenges in Organic Solar Cells. Sir, I want to mention the presentation time is 10 minutes. Kindly finish the presentation in 10 minutes, sir. Sir, kindly start the presentation. Yes, sir. Dr. Mahendra Singh, sir, you are not audible.
Hello.
Yes, sir. Now you are audible. Please continue the presentation.
Okay, sir. Thank you, and sorry for inconvenience. Okay, right now I just want to talk about my recent topic, and thanks to all of you to listening me. Okay, recent advances and challenges in organic solar cell. That is my topic, and that was. Uh, First of all, that was introduction. Energy security is a key parameter for the sustainable growth for any developing country. So that is our prime responsibility to develop an efficient and cheap technology which can be used to solve an energy crisis, as well as it should not deplete our environment conditions. Conversion of solar energy into electrical energy by using photovoltaic solar cell is a recent trend. Solar cell are classified as a organic and inorganic solar cell. In last 2 decades, solar cells are being seen as a promising technology to fulfill the need of energy demand, as well as meeting the environmental sustainability criteria. Photovoltaic devices consist of inorganic semiconductor materials, have high efficiency, but these are very expensive. This is a complex process to fabricate, and that's why it is limited our versatility. Right now, from last decades, the organic solar cell are being as a alternative of conventional ones. They are made of a thin film polymer and small molecules, and are fabricated by simple, cost-effective techniques. Organic materials are abundant in nature, and these are easy to handle. These mechanical flexibility allow mutual safe and application. Being lightweight and flexible, they can be fabricated in large shape. Organic solar cells are made of with organic semiconductor, in which it may produce electron and holes that are bounded in exciton, while separation of electron and holes occur in the interface. Some of the recent organic solar cells used are tandem solar cell, hybrid solar cell, and dye sensitized solar cell. And that was a pictorial representation, as we know very well that the solar energy is a part of renewable energy sources, and when the solar energy comes into the convert into electric energy, they convert in two parts, that is inorganic solar cell and organic solar cell. When here we are talking about the organic solar cell, in which the sketch of single layer organic photovoltaic cells represent electrode 1 and electrode 2, and between them organic material that was a small molecule or polymer. And the second one, that is a multi-layer, in which the between them electron 1 and electrode 2, electron donor and electron acceptor. The benefit of organic photovoltaic solar cell include low cost manufacturing, just because of soluble organic molecule, abundant materials. The wide abundance of building block material may reduce supply and price constraint. Flexible substrate, the ability to be applied to flexible substrate permits a wide variety of use. Production. The organic photovoltaic cells are categorized into classes: small molecule organic photovoltaic cell and polymer based organic photovoltaic cell. Small molecule organic photovoltaic cells use molecule with broad absorption in the visible and near infrared portion of electromagnetic spectrum. Highly conjugated systems are typically used for donating systems such as patholocyanamine, polyacines, and squarenes. Pyridines, dyes, and fluorines are often used as an electron accepting system. These devices are the most commonly generated by vacuum deposition to create bilayer and tandem architecture. The next is the polymer-based organic photovoltaic cells use a long-chain molecular system for electron donating material. For example, I mentioned it, along with the derivative fluorines as an electron accepting system. Like small molecule organic photovoltaic cells, these systems have small excitation diffusion length. However, their limitation is circumulated by high interface surface area with the active devices. Next is the dye-centralized solar cells are hybrid organic inorganic technology that are used small molecule absorber dyes. And these are the challenges which are facing right now. The biggest challenge of making the commercial viable in their low efficiency, which varies around 10 to 12% as compared to inorganic one. Semiconductor with a high band gap of organic solar cell are responsible for its low performance. They are sensitive towards oxygen and water. Some of the challenges are given below. How we can improve the efficiency of organic photovoltaic cell. Second one, that is what are the optimal properties of the material to be used to improving the efficiency of organic photovoltaic cell, and whether the experimental and theoretical study, we think about the what kind of method that we are going to employ. And last, that here we conclude that the organic solar cell will help us to meet energy security, sustainability, and reliability in the future. And these are the references from where we get the content. And thank you for all.
Hello.
Yes, sir.
Yeah, thank you, Dr. Mahendra Singh sir, for the
Okay, sir. Thank you.
insightful presentation.
Okay, sir.
Is
Thank
there
you.
any question from the audience? Okay, it seems there is no question, so we move to the next presenter. Our
Okay, sir.
next
Thank you,
presenter,
sir. Thank you.
yeah, sir. Thank you, sir. Our next presenter is Dr. Dhruti Sundar. It seems she is not connected, so we move to the next presenter, Dr. Samiran Sheikh.
Yes, sir.
And the title of the presentation is Determination of Malathion and Methoate Pesticides in Groundwater at Kota district of Rajasthan, India.
Am I audible?
Yes, madam, you are audible, but your voice is very low.
Okay. Now I am audible?
It is too much.
Okay, okay.
Can't decrease the
Now,
voice, madam.
okay, okay.
Yeah, madam, you can start now.
Okay. Good afternoon, respected faculty members and committee members and the audience. I, Sabrin Sheikh, research scholar in environmental engineering of Rajasthan Technical University. Today, I am here to present my research paper on determination of malathion and dimethoate pesticides in groundwater at Kota district of Rajasthan, India. Now, let's go through a brief introduction of pesticides, that what is actually a pesticide, where they are used. So basically, pesticides is a chemical substance, or they are the combination of compounds that are used to control and mitigate the cause that was by pest, that the damage caused by a pest. Pesticides have become environmental issues since they are difficult to store and dispose of safely. When it applied in large number, pollute soil and water, harming flora and fauna, and preventing plants from absorbing critical minerals and nutrients. For example, insects, plant pathogens, mollusks, animals, nematodes, etc. are the pests that compete for food and harm the property and indirectly spread diseases. Now, classification of pesticides. Pesticides can be classified in many ways. There is a general classification, there is a chemical nature classification, there is a toxicity classification. Here I include two classification, which is general classification and the chemical nature classification. In general classification, it can be classified as fungicides, herbicides, insecticides, bactericides. Fungicides are used to kill or suppress fungus or fungal spores, while herbicides are used to apply to kill the unwanted plants and restrict the growth of weeds, while insecticides um, are the chemicals that are used to control unwanted insects that are used in agriculture fields, gardens, hospitals, stores, etc. Bactericides are known as the germicide. They are also used as to suppressing the effect of the bacteria in soil and water. On the other hand, while talking about chemical nature, organic chlorine, they are not used nowadays, for example, DDT, because they are very toxic and they persist in the environment for a long duration of time. While talking about organophosphate nowadays used, they are also toxic, but their persistence in the environment is less as compared to organochlorine. Carbamate, synthetic pyrethroids are also the examples of the pesticides, and microbial insecticides are also the examples of pesticides that are used nowadays. Now, my main focus is on the organophosphate pesticide. So I'll discuss here what are actually these are. These are a class of very toxic agriculture compounds used to manage various insect pests. They are hazardous not only to the pest they are used to kill, but also to other living things. And their widespread use and unmanaged trash disposal resulting in contamination of soil, groundwater, and surface water. Now, groundwater contamination by pesticides. Pesticide residue damage precious resources, that is groundwater as well as soil in agriculture area. And about as the groundwater roughly meets 80% of rural home water requirements and 50% of urban water requirements in India. Now from the figure, we can see that when we apply pesticides in particular area, it not only affect the area but also the surroundings, such as when application of pesticides is done, some of the pesticide residues deposited on the plants, while some of the pesticide is leaching through the soil and indirectly affect the groundwater. Some of the pesticides sprayed to the air and it goes in the air and it contaminate the other areas also. Now study area. Kota district. Kota district lies in the southern eastern part of Rajasthan, and in Kota district I choose 4 areas for my research work, that is the Thatet, Raipura, Kheda, Rasulpur and Bundi Road. I choose these areas because lot of agriculture activities took place in these areas, so these areas were considered for my research work. Now, materials and method. There are 4 essential steps taken in my pesticide residue analysis. First is the sampling. In sampling, I took the water sample, groundwater sample from the tube wells, bore wells, and I collect that water from in the amber glass bottle. This amber glass bottle is used due to that pesticide residue present in the groundwater could not be absorbed on the walls of the plastic bottle. So plastic bottle initially was not used. So then the transport and storage of samples were done. Storage of samples, that is the sample of groundwater is stored at minus 32 degree, and the sample preparation was done for the extraction on HPLC. The solvent was used in as the acetonitrile. It is the mobile phase acetonitrile, and the water is used as a mobile phase. Then the last step is the cleanup. Now, while talking about the HPLC, HPLC is the principal separation technique for identify pesticides in the groundwater samples and for quantitative analysis. It has 4 to 5 main components. That one is the pump. The role of the pump is to force a liquid mobile phase at specific flow rate. Different flow rate is for different pesticides. Injector, that the injector serves to introduce the liquid sample into the flow stream of the mobile phase. Next is the column. The column has the stationary phase, that is called as stationary phase is used as a silica, separates the sample components of different pesticides. And the last is the detector. That detector can detect the individual molecules that come out from the column. Now here, I consider two pesticides here. That is, one is the dimethenate and other is the malathion. For dimethenate, the programming details are here. C18 column was used and wavelength was set as 205 nanometer. Temperature was 30 degrees centigrade and the flow rate was set as 1.0 milliliter per minute. Detector was used as the ultraviolet detector and the injection volume was 210 microliter and the mobile phase was in the ratio 60 is to 40 of acetonitrile and water. And the same, the malathion programming details for HPLC are C18 column was used, wavelength was set as 254 nanometer, temperature is same as for dimethenate, that is 30 degrees centigrade. Flow rate is here it is 1.2 milliliter per minute, and the detector was ultraviolet detector was used. Mobile phase ratio is 70 is to 30. Now the observation, analysis and result. Here the dimethenate and malathion pesticides have been detected from the different regions of quota and groundwater samples, that are the regions that the areas are Raipura, Thathed, the Kheda Rasulpur and the Bundi Road. The samples were collected for both seasons, that is the Kharif and the Rabi season for the year 2020 to 21. And the Kharif cultivation is mainly dependent on the rainfall, while the Rabi cultivation is dependent on groundwater. Main Kharif crops in the selected areas are jowar, rice, oilseeds, whereas the principal Rabi crops is coriander, wheat and mustard. Kharif season starts from July and ends in October, while Rabi season begins in November and ends in March. Now, these are the results of pesticide residue in groundwater samples at Thathed. T1, T2, T3, T3, T4. These are the different farms at the location, at the area that is selected at Thathed. And Kharif and for both seasons, Kharif and Rabi seasons. Now, all the samples collected from Thathed show that the dimethenate has a very high concentration in all the samples when compared to the adopted acceptable values given by US EPA, that is 0.007 milligram per liter. While for malathion, all the samples was detected under the prescribed limit given by US EPA, that is 0.07 milligram per liter. In sample T3 and T4, malathion was not detected because it was not used in these areas, or it might be under very less quantity. Now, while talking about the Raipura area, the result shows that 4 samples were collected again in Raipura from farm R1, R2, R3 and R4. Very high concentration in all samples, and R4 it was not detected, neither in Kharif season nor in Rabi season. And at R4 area, malathion concentration was high. Rest of the samples come under the prescribed limit, that is 0.07 milligram per liter. Now, talking about the Kheda Rasulpur, in Kheda Rasulpur again the dimethenate concentration is very high in all samples, and it was not detected in the K3 nor in the Kharif season nor in the Rabi season. While talking about the malathion, again malathion come under the prescribed limit, that is 0.07, and in at R4 at K4 it was not detected, while it was not used by the farmers. Now, talking about the Bundi Road result, again the dimethynotes are very high in concentration when compared to the standard limits, and in malathion it again comes under the limits, and for some areas it was not detected. Now, talking about the conclusion, it has been concluded from the present work that the groundwater seriously polluted due to discharge of pesticides, mainly dimethenate in groundwater at Kota region. All the samples collected from Thathed violating the standards of US EPA for dimethenate. Same scenario is observed for the samples of Raipura, Kheda Rasulpur and Bundi Road. From total 16 groundwater samples, 30 samples show the presence of dimethenate residue in groundwater. That means 81% of samples shows the presence of dimethenate. While talking about malathion, Malathion was detected under permissible limits, but near future it may violate the limit. So mitigation measures should be taken before things get out of control. Some of the precautions that can be taken, such as when airborne precautions, for example, avoid applying in windy conditions. Pesticides should be avoided in applying in windy conditions. Applying pesticides mechanically, for example, while taking about the groundwater precautions, avoid excessive irrigation after application of pesticide should be done. And if the soil is sandy and a location where groundwater contamination is known to occur, do not apply highly leachable pesticides in that particular area. So everyone should be aware that it can be affect the water quality of both surface and groundwater sources, and it should be some of the monitoring programs should be conducted by respective agencies and departments. Thank you.
Okay, thank you, madam. On the behalf of the organizing committee, I thank you for your insightful presentation.
Thank you.
So, in this direction, our next presenter is Dr. Dhruti Sundar. And the title of her paper is Facile Synthesis of Ultra-Thin Exfoliated Graphite Carbon Nitride. Is she connected with us? It seems she is not connected with us.
Okay, I think this was the last session for today. Thank you, Ketan sir, for hosting this session. Now, next I would like to invite Dr. Joginder Singh, session chair for this session, to please conclude the session.
Yes, I think there were very nice presentations. To be specifically mentioned, one from NIT Calicut, I don't remember the name. Very comprehensive work done. And the one by Dr. Ahmed, presented by Dr. Ahmed. Yes, so some very good papers were presented and very well presentations of the work here. And it is the conference organized of the international standards. So I thank you organizers for inviting me as the session chair of this session. Thank you.
Thanks from us, sir. So on the behalf of whole organizing committee, I would like to thank you for chairing this particular session and being with us. Thank you, sir.
Yes, and I will send you the recommendation by evening. Let me just go through the list you just send me.
Okay.
And I'll send you the.
Okay, sir. Thank you, sir. Thank you. So this marks the end of this session. Next, we'll be meeting after a lunch break. So I would request all the audience to please proceed for the lunch. But however, please remember to join back by 2:30 p.m. latest. We'll be starting the next session at 2:30. Good afternoon, everyone. In this afternoon session, we'll be starting with a keynote lecture first. The first keynote lecture will be delivered by Mr. Dipesh Patidarji on the topic of field usable water purifiers, challenges and solutions. Before I invite Dipeshji for the lecture, I would like to present a brief bio of sir. Mr. Dipesh Patidarji is working as Scientist F in Defence Laboratory Jodhpur. He is a chemical engineer from NIT Rourkela and Diploma in Management from IGNOU, and is currently engaged in design, development, field evaluation, productionization of field usable rugged, compact, mobile water purification systems. He has worked on preparation of UF and TFC RO membranes. He has 3 patents. He has published 3 research papers, presented 10 papers in conferences, received Technology Group and Laboratory Scientist of the Year awards. He has also worked on continuous polymerization industry for 8 years. I would like to invite Sri Dipesh Patidarji for the lecture. Please, sir.
Good afternoon. Respected our former director Ram Gopal sir, my colleagues from Defence Lab Jodhpur, my group colleagues. Today I will be presenting my talk on field usable water purification systems. First slide, please. Yes. So I will try to cover this topic, that is challenges and solutions for the development of field usable water purifiers. Next slide, please. Yes, so I am presenting this on my group's behalf, my colleagues Dr. Vikas Janu, Dr. Rajesh Kumar and Sri Manish Bhati and all my group members. We are basically working for the development of mobile and field usable water purifiers for use in the extreme climatic conditions. Next slide, please. Yes, so this is the outline of my presentation. Like, what are the broad requirements that we need to look into before designing of such systems, and what should be our approach for filtration processes, structure, maintainability, ruggedness, weight and volume. So to begin with, next slide please. Yes, as we see here, the field water purifier requirements are quite different from the conventional water purifiers. Here the basic requirements of a field water purifier is that they should be compact, lightweight, mobile as well as rugged, and essentially they need to be very user friendly, because in field conditions we normally do not have those facilities that we can avail in the static plants, and the logistic requirements needs to be very minimum, and our plant should be versatile. This I will explain in the coming slides. And next one please. So here we see that the contemporary systems, normally conventionally they are very large in size, quite heavy, they are stationary and they run on the mains power, and where there is provision for storage of water, for storage of the raw water as well as the purified water. Next slide please. So field water purifier, basically what are the requirements? The first one is what is the different varying feed water quality. Here what we understand is that normally when we design a system for using in field, the water sources will be different in different locations. So our plant should be capable of handling all these different kinds of water. So for example, if we talk of suspended or dissolved contaminants, they will vary. If we are operating this plant in Rajasthan, the water will be highly saline, and the turbidity will be there in the open water sources like IG canal. As we can see in the photographs, the water sources here in the Indira Gandhi canal, as well as one photograph of the Kawas area where there was a flood. So in these situations, the turbidity level goes very high. Now another important factor that the field water purifier needs to address is the location of water body in respect to our water purification system. So as we see, sometimes the depth of the water body is very down from our system. Sometimes it is too far away, and sometimes when we are lucky, we will have an intermediate tank just besides our plant. So that is the best scenario, but our plant should be capable of operating in the worst of the worst scenarios. And as far as power source is required, we have, during the design only, we have to decide whether our plant will be operating on mains or captive power source, or it will be running on some solar or another power source. And next slide please. So as we see, the when we start thinking of what is basically a design of a system, the design of any system comprises of taking decisions on various aspects of the system based on the requirements, based on the data that is available, based on the theoretical concepts that we understand about these systems. So the extent of mobility is an important criteria when we decide to design a field usable mobile plant. So there are different criteria, like whether our plant should be mobile by a roads only, or it should be mobile in the cross country, easily field maintainable. So by is that the suction itself is made floating on the surface of water, so that it does not touch the bottom of the water body, and it is not sucking any heavy particles like sand. So this is the when we try to address the sand particles. Coming to the micron level, we can have reusable use and throw or in situ backwash type filters. Next slide please. So particles, they can be addressed using these different types of filters as shown. These are candle type filters as shown in the middle. They can be like in-depth thread wound filters, or they can be pleated filters, or they can be repeatable use stainless steel mesh type filters. But the limitation of these stainless steel filters is that they need to be cleaned chemically or using high temperature solutions. So normally one of the simplest solution is to use the use and throw filters, but cutoff size will not enter the screen and they will be reflected from there, and only the smaller particles will get through. So when it comes to membranes, so when it comes to sheet type, normally backwashing or forward flushing is the only solution of cleaning these membranes, and these have some limitations. But when it comes to hollow fiber membranes can be very easily backwashed, or some manufacturers also provide the solution in the form of air bubble membranes. So these will essentially need compressed air. So these are sort of additional requirements these membranes will call for. But as such, these membranes, they take very limited volume and space in the system. Next slide please. So coming to the submicron or humus level membrane systems. So when the particle size is very much lower than the micron size and it is in humus level, then membrane systems or coagulation sedimentation is the solution. But coagulation sedimentation is not possible, or it is very difficult to attain in a mobile system. So it is always better to go for a these type of hollow fiber membranes, and these I already discussed, like air scoring, backwash. Important parameters are cycle time also, then chemical cleaning period, quantity of chemicals. These are also the factors which decide the type of membrane based systems that we can use in a mobile system. Now chemical cleaning also can be done in many ways, like there can be recirculation mode, once through mode, or it can be multiple use of tanks and pumps. So based on that, these decisions have to be taken right at the design stage, so that our system do not face any problem in the field. Next slide, please. Coming to the filtration processes, dissolved contaminants. So here as we see, dissolved contaminants can be removed in some basic processes like thermal processes, or a membrane based process, or it can be through adsorption also, or it can be chemical precipitation. So as we see in the photographs, the one of the processes that is used is chemical precipitation based. Here we understand that in such a situation, neither electricity is available, nor you have the luxury of using a pump also. So in that case, a simple precipitation type of chemical. For bigger systems where we can go for a captive power source, then we can afford larger membranes along with all the supporting items. So higher capacity systems are no doubt possible based on these membranes. But thermal processes normally are difficult to design for a mobile systems, but because normally thermal systems need a higher level of energy, and those energy can be obtained mostly either through an industrial setup or through a mains power supply. So membrane processes, when we go for the design, like flux is an important criteria. So if a new designer normally approaches a mobile system, the chances of misunderstanding is at the level of flux. Normally industry is there and maximum output is there. But when it comes to a mobile system, it is almost like different or reverse. Here the flux is usually kept at a lower side, so that your membranes, your processes, they operate for a longer time before the step for chemical cleaning or backwash comes. So normally when we call of a RO membrane systems, conventional systems are designed at a flux of around 30 to 35 liter per meter square per hour. But when it comes to mobile systems, the fluxes are normally kept at around 15 to 20 liters per meter square per hour. So based on our experience, I can say that keeping the flux at lower side, our systems have been very successful, and they operate for long periods without giving any trouble to the user teams. Now other parameters like type of vessel, end connections in these like membrane modules, they need to be universal. They should be easily replaceable. Spare should be available. We should not try to make tailor-made connections, tailor-made pipings for these plants. As far as possible, the things are universal. They will be more easily available, and they will be more rugged and of a conventional design. So like as we see, there is specific design also, but there is conventional components also being used. Coming to the membrane preservation, this is an important part because membranes are susceptible to microbial growth, scaling, fouling, and in extreme conditions of freezing, the membranes may get damaged if the water freezes. So in these conditions, special provisions are made in mobile systems or these even small backpack type systems, where we should have provision for preserving our system for very, very long periods. Suppose the plant is to be kept idle for more than 6 months. Then in that conditions, we should have provision of preserving the membranes and for a long period. Next slide, please. Now coming to for these membrane based systems, another important parameter is like stages and passes. So normally there is not much flexibility when it comes to mobile systems, but when the requirements are very stringent, like we want to attain a rejection level of more than 99%, then if we try to design the system, these two options normally come in front of us. One is the one or two stage system in which the concentrate from one stage goes to the another stage and the product is combined together. So in this has a limitation that as we go down these stages, the operating pressure gets lower and lower and our concentration of the salt increases. But here the advantage is that the one single set of feed side pump is required, and when we go for 2 pass, then the product from first pass is taken to another pump which repressurizes it and puts into the second pass. So here the rejection levels will be much higher, but normally these type of stages are not difficult, not attainable in mobile systems, because 2 pumps and too many pipelines, too many intermediate storage, it becomes difficult. So normally first type of array is normally used. Next one please. Next slide. Yes. So here coming to the structural design, here as we see our structure when it comes to a mobile system needs to be as light as possible. But on the other hand, it should also meet the ruggedness of the system. So these a designer faces this dilemma. He has to do lot of iterations in the design stage, and some testing also is to be done at the design stage before finalizing the overall structure of the system. And the design stage itself, the weight of the each component should be very, very clear. Similarly, these normally systems, mobile systems should be skid mounted. As we see in the photographs, these skid mounted systems are very easy to install or to repair, and if one skid is problematic or some malfunction occurs, you can change the whole skid itself. And mobile systems also need to have open structure where the doors or the panels of the system can be used for extra space for working. Similarly, these structural components also need to be evaluated. As we see in the photograph, each and every component, including the doors, are tested by giving different loads as per standards that are available. Next slide please. So this is the last slide where I would like to emphasize that when it comes to layout of the different components, we may have different options. Like the first we can see it is CG centric, in which the center of gravity of the different components is balanced. But the second, in which we see that it is process centric, in which the process components are kept as per the process convenience. And the third one is there where it is the operation or maintenance centric, in which lot of space is given for the team to operate. But as we see, a designer has to look into all these aspects, and based on the keeping some of the features of all these, he has to come out with a final design, and based on that the fabrication of the system is done. Next slide please. Now in conclusion, I would like to state that field usable water purifier design needs a totally different approach. So, and water parameters range. Why I am telling? Normally static plants are designed for a particular type of water which is available, but field purifiers, they need to be designed for a range of parameters, and environmental conditions play a major role in such systems design. And often it is not the most efficient design, but an most effective design that is suitable for a mobile system. Cost of such systems are not comparable with static systems. Normally what we do, we try to compare the cost per unit water generated or like that, but it is not possible to compare. Then important parameters for a mobile system design is system capacity per unit space, per unit weight. Then system footprint. These are the parameters which we have to take care, and based on this our system can be evaluated, our design can be evaluated. Then startup time, the time to get the first drop of water is often a very critical parameter when it comes to mobile systems. Then system storage in extreme conditions and for very long periods. And last is the very important, that is the end user perception is very, very important. Our system design should be such that all the perceptions of the end user are very, very correctly addressed. Next slide, please. Previous one, yes. So I would like to express my sincere gratitude to our Director, Defence Laboratory, DRDO Jodhpur, for granting me this opportunity to work in this field and present the learnings. I am also grateful to all my mentors and seniors, without whose support I would not have been here. I am thankful to my WQMG members, team members, who make an excellent team and are always there to carry out the toughest of the R&D work that we target. Thank you very much. Thank you. Jai Hind.
Any questions from the audience?
Okay.
Thank you, sir, for this very intellectual and insightful lecture. Moving ahead with the today's program, next we'll be starting our third and the last technical paper presentation session. The session chair for this session will be Dr. Vikas Januji, who is a scientist at Defence Laboratory, Jodhpur. So to begin with this session, I would like to invite Sri Ketan Jangirji, Assistant Professor, Chemical Engineering Department, to please proceed with the first session. First part.
Good afternoon, everyone. The first presenter is Dr. B. Uma Maheshwari, and the title of her paper is Performance Examination and Configuration ROX using cellulose-based nanoparticles from aquatic macropods, isotherm kinetics and mechanism.
No, sir, can you able to hear me?
Yes, madam, you are audible.
Yes. Can I start?
Yes, madam, you can start, but slides are not visible.
Yes, just a minute. I'm sharing, just a minute. Can you able to view my slides?
Madam, still slides are not visible.
Just a minute. I'm sharing. Hope it is visible now.
It is still not visible. I think it is taking its time.
Yeah, just a minute. I'm putting a slideshow. Just a minute. Yes. Is it okay, sir?
Yeah, I think slides are visible, and keep the slides in full screen mode, madam.
Yeah, I have kept in full screen. Can I start? Is it okay,
Yes,
sir?
madam. Yes, madam. Now can you start?
Yes. Okay.
Madam, I want to mention here that the presentation time is 10 minutes only. So try to finish in 10
Okay.
minutes. Yes, madam. Please
Oh,
continue.
yes. Oh, yeah, yeah. Thank you, thank you. So, respected professors from NBM universities and NBM eminent resource persons from Indian Desalination Association and DRDO Jodhpur and the jury members, a very warm good afternoon to one and all present here. I'm Dr. B. Uma Maheshwari, working as an assistant professor in the Department of Chemical Engineering, Coimbatore Institute of Technology, Coimbatore. So my research topic is performance examination and composition of ROX, that is Rosaxone, by using waste aquatic macrophytes. So the main aim is arsenic contaminated drinking water. Just a minute, it's getting. Yes, sorry for the inconvenience. So the environment is seriously affected by the release of hazardous heavy metals from the industries. The occurrence and the persistence of the heavy metal in the terrestrial and aquatic environment create a harmful impact in the ecosystem. So we all know various heavy metals such as chromium, lead, nickel, tin, etc. are available. So one such heavy metal is arsenic. It is persistent, bioaccumulative and toxic element widely distributed in the environment. It is introduced in the water or soil by anthropogenic sources such as mining, discharge from arsenic contaminated wastewater and some of its additives. So these are some of the sources and impacts of arsenic, that is from groundwater, surface water, through by means of fertilizers, volcanoes, mining, poultry. It is affecting the human chain. Arsenic contaminated drinking water will lead to the potential health hazards such as skin problems, stomach and respiratory tract cancer, followed by extensive liver damage. One of the arsenic organic form is Rosaxone, used as an animal feeding additive for effectively preventing the parasitic disease of poultry. Considerable amount of Rosaxone without metabolization in animals might be released from the poultry litter to the soil and water, can produce inorganic forms of the arsenic such as arsenic 3 and arsenic 5 oxidation state, displaying even higher toxicity. So to meet the stringent in drinking water standards, cost-effective arsenic removal technologies is urgently needed. So well, we all know some of the removal methods such as oxidation, ion exchange, adsorption, coagulation, flocculation, membrane separation, electrochemical treatment, followed by some hybrid technologies are used in the practice. Among these methods, adsorption is found to be perceived as a promising technique for the removal of the heavy metals from the wastewater. So lower solubility of solid metals with the high specific area and porous structure are mainly served as an adsorbent. So with this aim and the scope, my research objective is the present study we are focusing on the novel green synthesis of a cellulose-based nanoparticle.
Excuse me, madam.
Synthesized from
Sorry to
yes.
interrupt you, but the slides are not being changed, madam. Only the welcome slide is showing, madam. Slides are not being changed.
Just a minute. Is it moving now?
No, madam. Still, it's not moving. Okay.
1 minute. Let me press. Let me share once. Once.
कोई बात नहीं, उसका टाइम इतना ही है, उससे ज़्यादा हो गया तो उसको फिनिश करवाना ही है अपने को। आसपास मिल कर लेंगे
Just a minute, sir. I'm opening again. Yes, let me share. Yes, just a minute.
Sorry, Dr. Uma Maheshwari madam. And due to lack of time, we have to move to the next presenter.
Is it okay now? Is it okay, sir?
Okay, madam. Try to complete in 3 to 4 minutes, madam.
Sure.
Yeah, we have short of time, madam.
Yeah, sure. So I directly move on to my research objective. So the present study, we focus on the novel green synthesis of a cellulose-based nanoparticle synthesized from waste aquatic weeds. So rosazole is my organic arsenic contaminated. We have chosen for as a model pollutant. So here we have taken SCM analysis, FTIR, BET and thermogravimetric studies. And absorptive performance was based on pH, contact time, adsorbent dosage and metal ion concentration, followed by isotherm, kinetics and mechanism studies we have did. So this is a raw material and a model pollutant. So initially we have collected the aquatic weed, washed and sun-dried for 2 days, dried, finally grounded. So this bioabsorbent has been converted into nanoabsorbent by using a tetraethyl orthosilicate as a precursor, followed by 20 ml acetone and 0.5 ml HCl and 5 ml distilled water. It is stirred well, magnetically stirred for 2 hours and sonicated, finally dried and powdered. So this is a schematic setup that the experimental process has been taken in our laboratory. This is bioabsorbent process and followed by the nanoabsorbent process. So moving on for the characterization technique, initially we did with the FTIR. So here we have taken the samples for raw wheat as well as for the nano wheat to compare the studies. So 3600 to 3800 is mainly because of over-stretching of water, and 1463 peak is mainly due to the SiO stretching due to the presence of the silicate compound. So we have gone for the SEM analysis of both raw sample as well as for the nano sample. In case of raw sample, we have seen a non-uniform size distribution with an uneven shape. But when we gone for the nano sample, it appears to be non-aggregated with the smaller flakes and the craggy structure. And in the EDOX, we have seen some white patches that are present in the raw sample. It's mainly because of the non-mineral elements such as chlorine, potassium, tin, calcium, etc. that has been confirmed by our EDOX analysis. And finally, we went for the TGA analysis for raw and nano sample. At about 70 degree and 90 degree Celsius, dehydration of water molecule has been taken place. And in the case of raw lamina minor, 100 to 250 followed by above 390 degrees Celsius, volatilization of hemicellulose followed by cellulose degradation and loss of lignin content has been taken place. And 160 to 420 degrees Celsius, lignin degradation has been taken place. And we have also did by the characterization analysis for BET test also. The nano sample possesses 192 meters square per gram surface area compared to the raw sample. So with this characterization analysis, we have moved on to the adsorption studies. We have taken the stock solution. We have varied the metal ion concentration from 10 to 50 milligrams per liter with a dosage of 2 grams. We have placed in an orbital shaker, centrifuge, and finally we have analyzed for AS. So based on this parametric study, we went for pH studies, adsorbent dosage, metal ion concentration, and contact time. So for the initial pH studies, we have gone for the zeta potential. We have found that the pH value of pH value of LM is found to be 5.5. We have chosen the investigator between 1 to 10 for the pH value. So I checked the pH range from 1 to 10. So at an optimum of 5, we have obtained a maximum removal 98.23%. Followed by, we have gone for the adsorbent dosage with respect to 0.5 to 3 grams per liter. So increase the absorption, achieve the increase the adsorbent dosage.
Sorry to interrupt you.
Yes, sir.
I request to please conclude, sir. Conclude, madam.
Yes.
I request to please conclude.
Finally, adsorption, isotherm, kinetics, and studies has been taking place. Finally, the removal of rosaxone using lamina minor was studied. 98.23% reduction was achieved. Langmuir isotherm was found, and maximum absorption capacity is 116.22 milligram per gram was obtained. So from this, we have concluded that levanamide can serve as a potential and alternative absorbent for the removal of rosazole. So finally, I would like to acknowledge the support and the grant received to the research promotion stream from AICT, and also I convey my sincere thanks to the Principal Investigator Dr. B.M. Shivkumar sir for his valuable guidance and the support in the progress of the project. And also I convey my sincere thanks to the management, Principal of Coimbatore Institute of Technology for their support. Finally, these are some of the references. So finally, on my conclude, I wish to thank MPM Universities, DRDO and InDA for giving me this opportunity to present my research work in this conference. So sorry for the inconvenience caused. Thank you one and all.
Okay, thank you, Dr. Uma. I
Yeah,
thank you on the behalf of the organizing committee for this excellent presentation. Now move to the next presenter. Next presenter is Dr. Neetu Singh Parihar, and the topic of her paper is an advancement of photocatalyst for photoelectrochemical water splitting. Neetu madam, you are given 3 to 4 minutes. Kindly try to finish the presentation in 3 to 4 minutes.
Okay, sir. Am I audible?
Yes, madam, you are audible. Please continue.
Can you see my presentation?
Yeah, slides are visible, madam. Please continue.
Is it moving? Can you just check?
Yes.
Good afternoon, everybody. I am Neetu Singh Parihar, PhD scholar in the Department of Chemical Engineering, MBM University, Jodhpur, under the supervision of Professor Sushil Kumar Saraswat. My topic is an advancement of photocatalyst for photoelectrochemical water splitting. So you can see how the outlines of my presentations are. So basically, in this presentation, I have included with the copper-based photocatalyst for my photoelectrochemical research work. So as you can see, the picture depicts everyone is happy with the clean fuel, that is hydrogen. So that's why I am working on hydrogen production by the photoelectrochemical water splitting. How hydrogen is the future fuel, you can see it is the highest mass specific energy content among 119.93 megajoules per kg compared to 44.5, because it is clean, energy efficient and abundant in nature. It is also a flexible energy carrier. You can see by different methods we can conclude to the hydrogen by using different thermolysis method, electrolysis or like conversion methods. You all know because it fills the gap of scarcity of the fossil fuels and the petroleum products. So we need to move to the renewable and clean fuel as important for the society. You can see how hydrogen is being produced from the water and you can store it here. And recently, if you know the news of Toyota cars, they have launched the hydrogen fuel based cars. So this is currently in international, Japan and so many countries, they are using the train based on the hydrogen. So it is a very loose topic for now. You can see how are the different methods you can conclude with the hydrogen by using photoelectrolysis method or fuel cell methods or photovoltaic method. Everybody is using sunlight nowadays to create so many clean fuels like hydrogen. Way for the general hydrogen fuel, and it's the process of separation of water into hydrogen and oxygen. So there are various photocatalysts that we can say semiconductors for the photoelectrochemical water splitting. I have taken copper base, but you can take according to the band gap, TiO2 or like zinc oxide or cadmium sulfate, gallium arsenide. There are various, but you have to see the corrosion things and more, which is included in the presentation also. There are some barriers. So how photoelectrochemical water splitting works? This is the method. You can see there are the reference electrodes, counter electrode and working electrode. So how hydrogen is produced on the anode, and oxygen is produced on cathode. So how the reactions work, you can see here by the taking sunlight, but I used here a solar source, which is of 1 sun intensity. So these are some reaction which is involved. How band gap is taken from valence bank to conduction, where this is gap is the band gap we call it. So there are the advantages. It is no emission, any harmful pollutants you can see. Sustainable method, efficient and eco-friendly and very clean fuel. What are the challenges? You can face so many challenges like minimum internal resistance losses must be there, and you have to check for the corrosion life, you have to check for the photon utilization efficiency. It must be, the electrode must be photo effective, you can say. And there are, this is the main thing which I want to tell you here. Water splits at a voltage of 1.23 electron volt. Okay, so we after going far than 1.23 electron volt, then only water will be splitting by any photocatalyst or any electrode. So you have to check for that. Moreover, there are some properties for copper photocatalyst, like it is a p-type semiconductor, it is ideal band gap of like around 2 electron volts, it is cheap, it is low toxicity, and main thing, it results in a maximum hydrogen, solar to hydrogen efficiency comparative to different photocatalysts of about practically 18%. So these are some copper oxide.
Excuse me, madam. I'm sorry to interrupt you. Actually, we are short of time, so I request to please conclude your presentation.
Yeah, I'm just concluding.
Yes, sir. Yeah, madam, please conclude it.
Yeah, we have just used photoelectrochemical deposition method, you can see here, and this is the main findings of my research. We have anodized at 3 molar NaOH and with glucose and 1 molar Na2SO4 in 1 sun conditions. These are some findings, various reactions involved in it. So this is the Cu2O deposited on the copper. These are some small islets you can see. And this is the photocurrent density and time curves by light on, light off. And these are the conclusions. New method to synthesize high quality Cu2 nanowire samples have been developed. Synthesis photocatalyst shows super physical properties compared to the conventional player sample by photoelectrochemical depositions, and those samples demonstrated 25% enhancement in the photocurrent of CuO or Cu2O on Cu, which made the photo-generated electron hole pair efficiently separated. There are my references which I've used. Thank you so much.
Thank you for this presentation, ma'am. With this, we'll mark the end of this technical session. I would ask our session chair, Dr. Vikas Januji, to please conclude.
So there
Hello,
were.
hear me, sir? Hello. Sorry for interruption. Hello.
Yes. Yes, sir.
Hello. 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 Sir, my presentation not done. Hello.
of Mr. बैठ ही नीचे. A very good afternoon to all our distinguished guests, speakers, faculty members, students, and all participants gathered today with us. I welcome you all to this valedictory session of this two-day international conference on desalination and water treatment, recent technological advancement, challenges, opportunities, and annual Congress of Indian Desalination Association 2022. The conference is jointly organized by MBM University, Defense Laboratory, and Indian Desalination Association. I am delighted to share with all of you that Professor Santanu Chaudhary, Director, IIT Jodhpur, Engineer Ravindra Kumar, Director, Defense Laboratory Jodhpur, Professor Ram Gopalji, Ex-Director, Defense Laboratory Jodhpur, and Professor Ajay Kumar Sharma, Honorable Vice Chancellor, MBM University, are present here with us today. Along with our distinguished guests, we also have our Dean, Professor Sunil Sharma, and Organizing Secretary of the conference, Professor Sushil Saraswat, present with us at the dais today. Before we start this valedictory ceremony, in line with our traditions, I would like to request our guests to please offer garlands to Ma Saraswati. I also invite a team of students to sing the Saraswati Vandana. Please, sir.
Ya kundendu tushar har dhavana, ya shubhra vastravita, ya veena varadanda mandita kara, ya shweta padmasana, ya brahmanchut shankara prabhitibhi devai sada vandita, saman patu saraswati bhagavati, niche shazadya paha, shuklam brahma vichar shar parma, adhyam jagat vyapini, veena pustak dharini mama yada, jadyandhakarapaha, haste sphatikmalikam vidadati, padmasane sansthitam, vande tvam parameshwari bhagavati, buddhi pradam sharadam, buddhi pradam sharadam. Thank you.
Thank you, students. And thank you, guests. Moving ahead with today's program, I would like to invite Professor Sushil Saraswat, Organizing Secretary of this conference, to welcome our chief guest, Professor Santanu Chaudhary ji, by offering him a bouquet. Proceedingly, I would like to invite Professor S.K. Singh, Professor Civil Engineering Department, to please come on stage and welcome our special guest, Shri Ravindra Kumar Ji, Director, Defense Laboratory. Next, I would like to invite Professor S.S. Sakhla sir to please come on stage and welcome our special guest, Professor Ram Gopal Ji, Ex-Director, Defense Laboratory, Jodhpur. ले जाओ, ले जाओ. Next, I invite Professor Anil Vyas Ji to please come on stage and welcome our Honorable Vice Chancellor and Presiding Guest, Professor Ajay Kumar Sharma sir. Next, I would like to invite Professor Arvind Kumar Verma sir to please come on stage and welcome our Dean, Professor Sunil Sharma sir. I take this opportunity to invite our Dean, Professor Sunil Sharma sir, to address this august gathering. Please, sir.
मंच पर उपस्थित हमारे आज के अंतर्राष्ट्रीय कॉन्फ्रेंस के समापन समारोह के मुख्य अतिथि आईआईटी जोधपुर के डायरेक्टर प्रोफेसर डॉक्टर शांतनु चौधरी जी, परम आदरणीय, मैं माफ़ी चाहता हूँ, मुझे उनका नाम पहले लेना चाहिए था, हमारे सबके पूजनीय परम आदरणीय वरिष्ठतम वैज्ञानिक डॉक्टर राम गोपाल, जो कि डॉक्टर एपीजे अब्दुल कलाम साहब के साथ भी इन्होंने काम किए हैं और वो बहुत ही देश का नाम जो रोशन हुआ था। मैंने आपके अधीन काफ़ी रिसर्च वर्क किया था, अपनी मास्टर ऑफ इंजीनियरिंग का भी और पीएचडी का भी कार्य किया था, और आपने मेरे को एक नाम दिया था, मेरे नाम का अर्थ समझाया था। सुनील का मतलब जानते हो तुम? मैंने कहा बताइए सर। बोले सु मतलब अच्छा, नील मतलब जल, और तुम जल पर ही काम कर रहे हो, तो तुम अपने नाम के अनुरूप जा रहे हो, आगे बढ़ोगे। आज उन्होंने फिर मुझे एक नया कॉम्प्लीमेंट दिया कि तुम हेल्दी, वेल्दी और वाइज हो गए हो। वाइज तो मैं नहीं हुआ हूँ, इतना तो मतलब मैं नहीं समझता हूँ, लेकिन हेल्दी और वेल्थ तो जो बड़ों का आशीर्वाद है वो सबसे बड़ी संपत्ति है, लेकिन हेल्दी जरूर हो गया हूँ, 100 किलो के आसपास हो गया हूँ। और अब मैं एक टाइम खाना खाता हूँ 15 साल से लेकर सर, लेकिन फिर भी पतला हो नहीं पा रहा हूँ। देखो सब क्या करें। तो आज हमारे बीच में इतने वरिष्ठ वैज्ञानिक उपस्थित हैं कि आपको दर्शन मात्र से ही हमारी जो रोम जो है हमारे एकदम से कंपित हो गए, और ऐसा लगा कि वास्तव में यहाँ पर एक ऊर्जा है, विज्ञान की ऊर्जा यहाँ पर आ गई है आपके रूप में। तो आपका एमबीएम इंजीनियरिंग कॉलेज के अधिष्ठाता होने के नाते और इंजीनियरिंग एमबीएम इंजीनियरिंग यूनिवर्सिटी के स्टूडेंट्स और टीचर्स की तरफ से आपका सादर अभिनंदन करता हूँ। मंच पर उपस्थित, जैसा कि मैंने कल बताया, विज्ञान के वीर प्रोफेसर डॉक्टर रविंद्र कुमार, ये प्रोफेसर अजय शर्मा ने नाम दिया था कल इनको गार्लैंडिंग करते टाइम। अजय शर्मा जी स्ट्रक्चर वाले छोटे वाले, हमारे एसके सिंह भी 2 है और अजय शर्मा भी 2 है। तो उन्होंने जो नाम दिया बहुत अच्छा नाम दिया विज्ञान वीर के रूप में आज फिर हमारे बीच में उपस्थित हैं, और प्रोफेसर सुरेंद्र कुमार का हार्दिक अभिनंदन करता हूं, और मेरे अपने हमारे परिवार के मुखिया, मेरे बड़े भ्राता, एमबीएम विश्वविद्यालय के संस्थापक कुलपति, एनर्जेटिक, ऊर्जा से भरपूर, 24 आवर्स भी अगर काम करने के बाद भी मैंने इनके चेहरे पर, हम उदास हो जाते हैं, हमारे शर्ट निकल जाता है, कफ इधर से उधर हो जाता है हाथ का, और चेहरे लटक जाते हैं, लेकिन सर के चेहरे की जो मुस्कुराहट वैसी की वैसी, सुबह उठते ही वैसी, शाम को वैसी, गुड मॉर्निंग करता हूँ, लिस्ट ऑफ वर्क आ जाता है व्हाट्सएप पे, आज ये कर, वो करना है, इसकी रिपोर्ट कर, उसकी रिपोर्ट कर। इतना एनर्जी लेवल मैंने अपने जीवन में जो हमारे कुलपति के रूप में जो देख रहा हूँ वो किसी के लिए पास देखा नहीं। हर वक्त चिंतित रहते हैं किस प्रकार से मैं एमबीएम विश्वविद्यालय के लिए कुछ नया करूं, हर रोज नया एमओयू, हर रोज नया विचार, हर रोज नया नवाचार, और इन सब चीज़ों के लिए मैं, मेरे अनुज और हमारे यहाँ के नवनियुक्त प्रोफेसर और इस केमिकल विभाग के विभागाध्यक्ष, और बहुत ही बल्कि ये कहा जाए कि एमबीएम विश्वविद्यालय में एक सही रूप में एक प्रोफेसर के पास में जो बायोडाटा इस उम्र में जो आईआईटी लेवल पर भी बहुत कम देखने को मिलता है कि आपके पास 8 पेटेंट हैं। प्रोफेसर सुशील सारस्वत जो कि इस कार्यक्रम के कोऑर्डिनेटर हैं, कई बार क्या होता है कि हमको अपने लोगों के गुणों को छुपाना पड़ता है, लेकिन आज माफ़ी चाहता हूं सुशील कि मेरे मुंह से निकल गया, क्योंकि हम कहीं ऐसा नहीं हो कि नज़र लग जाए। शांतनु साहब यहाँ बैठे हैं, आईआईटी के डायरेक्टर, उनकी नज़र आप पर पड़ गई और आपको ले गए तो हमारा एमबीएम सुना हो जाएगा, क्योंकि आईआईटी वाले ढूंढते रहते हैं। आईआईटी वाले जो है वो जैसे अमेरिकन्स जो हैं वो पूरे वर्ल्ड में जो है स्टफ को ढूंढते रहते हैं कि यहाँ से ले लूँ, वहाँ से ले लूँ, वो सिर्फ मैनेज करते हैं और लोग काम करते हैं। इसी प्रकार आईआईटीएंस भी जो है डायरेक्टर्स जहाँ भी जाते हैं ढूंढते रहते हैं उनकी निगाहें कि कौन सा प्रोफेसर इतना एनर्जेटिक है, उसके पास पेटेंट है, रिसर्च में ओरिएंटेड है, और ऐसे लोगों को वो ढूंढते रहते हैं। तो मैं आपसे करबद्ध निवेदन करता हूँ कि अभी हमारे एमबीएम विश्वविद्यालय को सुशील की बहुत ज़रूरत है, उसको बहुत आगे बढ़ाना है, और इसके लिए मैं आपसे विनती करता हूँ और सुशील का बहुत ही अभिनंदन करता हूँ। अब मेरे सामने उपस्थित हमारे सीनियर प्रोफेसर एसके सिंह जो कि हमारे एमबीएम विश्वविद्यालय के ड्राफ्ट के संस्थापक रहे हैं। इट वॉज द ब्रेन चाइल्ड ऑफ प्रोफेसर एसके सिंह, एमबीएम विश्वविद्यालय, जो कि इन्होंने BR पवार साहब के ड्राइंग रूम में बैठ करके तैयार किया था और आज वो मूर्त रूप ले रहा है। तो इनको जब से एमबीएम विश्वविद्यालय की स्थापना हुई है मैं इनके चेहरे पर कभी हंसी देख ही नहीं पाया, आज ही देखा है, क्योंकि हर वक्त ये भी चिंतित रहते हैं। क्या होता है कि भगवान को जब क्या होता है कि हम ईश्वर की आराधना करते हैं, और ईश्वर की आराधना करने के टाइम में जब हम ईश्वर के करते करते अचानक कोई बताता है कि भाई ये दरवाज़ा खोलो, ईश्वर मिल जाएगा, और जैसे ही दरवाज़ा खोलता है तो आदमी चिंतित हो जाता है, क्योंकि वो रहता ही नहीं, वो स्वयं अस्तित्व जो विलीन हो जाता है। तो ये हमारे सिंह साहब जो है 4 साल से एमबीएम विश्वविद्यालय कर रहे थे, अब जैसे ही आ गया विश्वविद्यालय तो अब इनके ऊपर पूरा लोड आ गया, अब सब चीज़ ये भी करो, वो भी करो, 24 घंटे का दिन कम पड़ रहा है। लेकिन मुझे बड़ा गर्व है कि मैं मेरे छोटे भाई के रूप में और कुछ समय मेरे विद्यार्थी के रूप में भी आप रहे हैं, जब मैं शिक्षकता यहाँ पर ज्वाइन किया था उससे पहले आपने, और बहुत ही अच्छा हमारा 30 वर्षों का हमारा साथ में अनुभव रहा, और मुझे गर्व है कि इतने बड़े वैज्ञानिक हमारे जो है डिपार्टमेंट में, सिविल डिपार्टमेंट की शान HOD के रूप में मौजूद हैं, और यहाँ पर हमारे दूसरे भी जो प्रोफेसर्स विद्यमान हैं, सभी हमारे मेरे जो है वो हमारे कुलपति महोदय के दरबार के सारे नवरत्न हैं, कोहिनूर हैं, जितने भी यंग प्रोफेसर्स हैं उन लोगों के लिए भी मैं बहुत बहुत शुभकामनाएं देता हूं, और बहुत ही आगे बढ़ें वो। और इस प्रकार से इन सब लोगों के, क्योंकि एकेडमिक्स के अंदर और रिसर्च में ईर्ष्या बहुत ज़रूरी है, क्योंकि ईर्ष्या और के बगैर जलन नहीं होनी चाहिए, लेकिन ईर्ष्या तो जरूर भाव होनी चाहिए, ताकि एकेडमिक्स में ईर्ष्या भाव से क्या होता है, आगे बढ़ता है व्यक्ति कि नहीं मुझे भी कुछ करना है। तो आप लोगों को भी इस प्रकार का भाव उत्पन्न हो और आप लोग अच्छी रिसर्च करें। स्टूडेंट्स जो यहाँ से निकले उन लोगों को मैं मेरा ये संदेश है कि इस प्रकार की इंटरनेशनल कॉन्फ्रेंस आपके युवा विभागाध्यक्ष के मार्गदर्शन में हो रही है, तो आप लोग भी अभी से रिसर्च पेपर लिखना शुरू करें। प्रोफेसर वर्मा जो है कल लंच में बता रहे थे, हमारे ट्रेनिंग एंड प्लेसमेंट ऑफिसर है, और इनके दिशा निर्देश में हम लोगों ने कोरोना काल में भी 96% प्लेसमेंट हासिल किया है, और हम इंजीनियरिंग कॉलेज की नाम हमारा आपने स्थापित किया है। कल लंच के समय आप कह रहे थे सुशील तू चिंता कर रहा था, अब कैसा लग रहा है? बोला सर अच्छा लग रहा है। तो मैंने कहा था ना बस करो डालो। प्रोफेसर वर्मा का एक ही डायलॉग है, कई बार किसी भी काम को करना है तो कर डालो, अपने आप हो जाएगा, हो जाता है, शुरू कर दो उसको। तो आपने प्रेरणा दी हम सब ने भी प्रेरणा दी और सुशील ने इस जो है अंतर्राष्ट्रीय महोत्सव को, अंतर्राष्ट्रीय कॉन्फ्रेंस को, एक शैक्षणिक महोत्सव को मूर्त रूप दिया ऑफलाइन मोड और मिक्स्ड मोड में। कल हमारे बीच में जो पहली बार ऐसा हुआ मेरे पूरे जीवन में, जो 33 वर्ष की नौकरी में, केंद्रीय मंत्री ने जो है, और बहुत मतलब एक तो होता है सिर्फ फीता काटने के लिए मंत्री महोदय आए, नहीं ऐसा नहीं, एक एकेडमिक्स के रूप में, एक रिसर्चर के रूप में, एक मोटिवेटर के रूप में उन्होंने जो इस प्रकार से माननीय गजेंद्र सिंह जी शेखावत ने जो हम लोगों को प्रेरणा दी, और उससे भी ज़्यादा मैं आपको चरण छूकर जो है वो एक आप सब लोगों को कुलपति जी के चरण छूकर कहना चाहता हूं कि कुलपति जी तो एक मिनट भी रुके नहीं, उन्होंने सुबह से लगा के शाम तक 3-4 टीमें रिवाइज की, हम लोग बैठे, मैंने कहा नहीं ये नहीं वो नहीं, मैं कहा सिंह साहब को रखो इसमें, SK सिंह को कन्वीनर बनाओ और साथ में इन दूसरे लोगों को जोड़ो, और ऐसा करते करते हम रात तक जो है करके, और रात को भी शायद आपने एक आधा नाम और जोड़ दिया, सुशील को मैंने फ्री रखा था, अनिल व्यास को जोड़ा था, आपने सुबह आगे घोषणा कर दी सुशील भी रहेगा। तो मतलब आप हर वक्त जो है, कल उन्होंने काम बताया मंत्री जी ने, और आपने आज पूरा मीटिंग करके डायरेक्टर साहब रविंद्र कुमार जी आए और उनको आते ही बता दिया देखो हमने ये टीम बना ली है, अब आप अपने जो है वो 2-3 मेंबर बना दीजिए, और वो सारे मेंबर बन के अभी हम लोगों ने एक 10 मिनट के लिए जो एक मीटिंग जो थोड़ा सा पहले होती है, कहीं पर भी कार्यक्रम से पहले मिलना होता है, वहाँ पर भी हमारे कुलपति महोदय खाली नहीं बैठे, ना खुले बैठते हैं ना बैठने देते हैं। तो अच्छा है सर, हम लोग एक पॉजिटिव वे में कह रहे हैं आपको, तो वो उन्होंने कर दिखाया, और आज एक नया एक जो चीज़ है, क्योंकि फंड सबसे बड़ी चीज़ होती है फंड, जब केंद्रीय मंत्री कह रहा है कितना पैसा चाहिए, करोड़ों अरबों ले जाओ, ये काम मुझे करके दो, और आज ये प्लानिंग हो गई है, कमेटी बन गई है, और इसकी कमेटी के आउटकम्स जो आएंगे और ये जो सेंटर बनेगा, ये पश्चिमी राजस्थान के लिए एक बहुत ही बड़ा एक मील का पत्थर साबित होगा। बहुत तो इन्हीं शब्दों के साथ में मैं आप सब लोगों से अनुमति चाहता हूँ, न्यूनाधिक कह गया हूँ तो उसके लिए माफ़ी, और आप लोगों को कोई भी तरह की जो मेरी बात से कोई बुरा लगा हो तो माफ़ी चाहता हूँ, और अच्छा लगा हो तो ज़रूर उसका जो है अनुकरण करें, उससे प्रेरणा लें, और आप सब लोगों का हार्दिक आभार, धन्यवाद।
Thank you for such a motivating address, sir. Moving ahead with the program, next I would like to invite our special guest, Shri Ravindra Kumar ji, to please address this August gathering. Please, sir.
सम्मानीय डॉक्टर रामगोपाल साहब, फॉर्मर डायरेक्टर डिफेंस लेबोरेटरी जोधपुर, फॉर्मर प्रेसिडेंट InDA, and the leading figure of starting research in water technology in Jodhpur and in DLJ. सम्मानीय प्रोफेसर शांतनु चौधरी साहब, डायरेक्टर IIT जोधपुर and chief guest of today's function. सम्मानीय प्रोफेसर अजय कुमार शर्मा साहब, वाइस चांसलर MBM यूनिवर्सिटी जोधपुर, प्रोफेसर सुनील शर्मा साहब, डीन MBM यूनिवर्सिटी जोधपुर, प्रोफेसर सुशील सारस्वत साहब, organizer of this conference, all faculty members of MBM and JNU University, delegates of this conference, students of MBM Engineering College, ladies and gentlemen, आप सभी को मेरा सादर नमस्कार, अभिनंदन, बधाई इस बात की कि इतना अच्छा कॉन्फ्रेंस आप लोगों ने ऑर्गेनाइज किया। साथ ही बधाई इस बात की कि एक जो ज्वलंत समस्या है पश्चिमी राजस्थान की, उसके ऊपर आपने ये बड़ा ही सार्थक संवाद डिफरेंट एजेंसीज में स्थापित किया। मुझे याद है मैंने अपना कैरियर डॉक्टर रामगोपाल साहब के साथ ही शुरू किया है, उन्हीं की मेंटरशिप में शुरू किया है, उनकी गार्जियनशिप में शुरू किया है, और जो प्रोजेक्ट सुजलम चलाया गया प्रोफेसर अब्दुल कलाम साहब के विजन के हिसाब से, जिसमें कल भी मैंने बताया था हम लोगों ने करीब 30 वाटर डिसैलिनेशन प्लांट, और हर प्लांट की कैपेसिटी 30,000 लीटर पर डे थी, वो स्थापित किए। उस समय अब्दुल कलाम साहब 3 बार या उससे ज़्यादा यहाँ गांवों में पधारे थे। उन्होंने इस परियोजना का उद्घाटन भी किया और परियोजना का समापन भी किया। उसमें जो नेतृत्व डॉक्टर रामगोपाल साहब ने प्रोवाइड किया वो आज से करीबन 20 साल पहले की बातें है। अगर उस विजन को चालू रखा जाता सर तो शायद अभी तक बहुत कुछ अचीव किया जा सकता था, लेकिन कुछ कारणवश, क्योंकि जो डिसैलिनेशन टेक्नोलॉजी होती हैं बहुत O&M ओरिएंटेड होती हैं, उनका ऑपरेशन एंड मेंटेनेंस ज़्यादा चाहिए, तो शायद हमारा मैकेनिज्म वैसा डेवलप नहीं हो पाया। दूसरा कारण था कि यहाँ इंदिरा गांधी कैनाल आ गया, थोड़ा वाटर प्रॉब्लम का स्ट्रेस जो था वो कम हुआ है, लेकिन फिर भी समस्या उतनी ही गंभीर है पश्चिमी राजस्थान के संदर्भ में, सिविलियन के लिए भी और हमारी जो सशस्त्र सेनाएं उनके लिए भी। तो उसके लिए कल जैसा माननीय मंत्री जी के साथ में डिस्कस हुआ था और एक बार मैंने पूर्व में भी डॉक्टर रामगोपाल साहब से भी डिस्कस किया था सरस्वती रिवर का और एक्यूफर का। सर वही टास्क दिया है जल शक्ति मिनिस्टर ने कि जो एक्यूफर में काफ़ी अधिक मात्रा में उनके पास क्वांटिटी भी थी, अराउंड 100 बिलियन क्यूबिक मीटर, उतनी क्वांटिटी का वाटर अवेलेबल है अंडरग्राउंड में। तो एक तरीके से माँ सरस्वती अंदर विराजमान है। जो वेद लिखे गए वो सरस्वती के तट पर ही लिखे गए और कुछ कारणवश वो सरस्वती ऊपर से डिसअपियर हो गई और लेकिन अंदर अभी भी वो बह रही है। इसीलिए हम देखते हैं कि जोधपुर के आसपास कहीं बिल्कुल मीठा पानी है, उससे आप 50-60 किलोमीटर से चले जाइए खारा पानी है। तो ये जो अंदर जो जल का अथाह भंडार भरा पड़ा है, अगर हम इसका दोहन कर सकें, इसको मालूम कर सकें और इसका दोहन कर सकें, तो वो जो सशस्त्र सेना है उनको भी सशक्त करेगा, उनके ऑपरेशन को भी बहुत बड़ा संबल प्रदान करेगा। क्योंकि डेजर्ट में जब सशस्त्र सेना आगे बढ़ती हैं, अगर उनके पास में पीने के योग्य पानी नहीं है तो वो लड़ाई नहीं कर सकती। जैसा कि अभी सुनील शर्मा साहब ने बताया, MBM से टीम डिसाइड हो गई है, हम लोगों ने भी डिस्कस कर लिया है। मैंने कल चेयरमैन साहब को भी मैसेज भेजा था, उन्होंने भी ओके कर दिया है। तो जल्दी ही हम इसके लिए प्रोजेक्ट प्रपोजल बना के हम जल शक्ति मंत्रालय को भेजेंगे। उस प्रपोजल में 3-4 कंपोनेंट बहुत ज़रूरी हैं। एक तो क्या है, अभी हम सैटेलाइट इमेजरी से पता पड़ रहा है कि एक्यूफर में पानी है, लेकिन जब आप ग्राउंड पे जाएंगे तो इट इज़ वेरी डिफ़िकल्ट कि कहाँ पर पानी है और किस क्वालिटी का है, कितना यील्ड है और कितनी डेप्थ पर है। अगर ये इन्फॉर्मेशन हमको मालूम पड़ जाए और फिर वहाँ पर ड्रिलिंग की जाए वेल की, तो हम इस रिसोर्स को निकाल सकते हैं। तो उसके लिए जो हमारा हम लोगों ने पहले डिस्कस किया है और कुछ बेस वर्क भी किया हुआ है, माइक्रोवेव बेस्ड सेंसर्स डेवलप करना है जो अंडरग्राउंड पेनिट्रेट करके देख सकें कि कहाँ पानी उपलब्ध है, कितनी मात्रा में उपलब्ध है। उसके बाद में वहाँ ड्रिलिंग हो और क्वालिटी क्या है उस वाटर की, उसके हिसाब से ट्रीटमेंट टेक्नोलॉजी लगाई जाए। तो ये एक होल प्रोजेक्ट बना के हम इसको सबमिट करेंगे और मुझे आशा है जल्दी ही ये सैंक्शन होगा और इस पर कार्य आरंभ होगा। IIT जोधपुर ने भी जो एक इनिशिएटिव लिया है सिटी सेंटर वाला, उसमें भी ये उपयोगी साबित होगा, ऐसी मेरी आशा है। अभी इस पूरे सत्रों के दौरान आपने अच्छे रिसर्च पेपर्स को सुना होगा। मुझे आशा है आप सभी को बहुत ज्ञान प्राप्त हुआ होगा। मेरे साथी, मेरी टीम भी यहाँ मौजूद थी, उन्होंने भी अपना कार्य यहाँ डिस्कस किया है और साथ ही जो दूसरी इंस्टीट्यूट्स ने कार्य प्रोजेक्ट किया है, उसको देखा है, सुना है, तो मुझे लगता है कि ये जो इंदा की कॉन्फ्रेंस थी वो बहुत ही सक्सेसफुल रहा है। सबसे ज़्यादा मैं सारस्वत साहब को बधाई देना चाहता हूँ कि उन्होंने इतना प्रयास किया, सभी स्टेक होल्डर्स को यहाँ बुलाया और एक मंच प्रस्तावित किया। ये जोधपुर के लिए भी अच्छी बात है और इंदा के लिए भी अच्छी बात है। मैं भी इंदा से एसोसिएट रहा हूँ, उस समय डॉक्टर रामगोपाल साहब इंदा के प्रेसिडेंट थे और इन्होंने मुझे एडिटर बनाया था। 4 वर्ष तक हमने वो इंदा न्यूज़लेटर निकाला है। तो मैं देखता हूँ कि सर घड़ी गोल होती है, धरती छोटी होती है, तो कहीं ना कहीं एफर्ट्स आके कल्मिनेट होते हैं। और मुझे बहुत खुशी है कि सर मेरा रिटायरमेंट अब जून में है, तो तब तक शायद कुछ और अच्छा हो जाए जोधपुर शहर के लिए और देश के लिए भी, ऐसी मेरी आशा है। आप लोगों ने मुझे यहाँ आमंत्रित किया, मेरा सम्मान किया, उसके लिए मैं हृदय से आप लोगों का आभारी हूँ। धन्यवाद।
Thank you, sir. Thank you for this delightful address. Moving ahead with the procession, I would like to invite our special guest, Professor Ram Gopal ji, to please address this august gathering. Please, sir.
परम आदरणीय आज के मुख्य अतिथि Professor Shantanu Kumar ji, my friend, colleague, Rabindranath ji, engineer, and Professor Sharma and other friends, I am extremely delighted among the galaxies of the Vice Chancellor. As my friend Ravindra Kumar told you, Dr. Kalam used to call me waterman of India. Why? One day we were sitting in the Prime Minister's office just for some discussion. They said, can you provide safe drinking water to 100 villages of Bardmer and Jaisalmer? I said, that's not possible. There's no water. I don't know. DRDO is known for what? I said, it will take unnecessarily 33 to 34 crore rupees. On his script, he wrote, in principle sanctioned, put up the project. And we got the project. I named the project, as just told by Sunil, Sujalam, Sufalam, Malaj, Sitalam. 1974, I wrote a paper, Appraisal of Water Quality of the Thar Desert, and gave a hypothesis that there is ample oil beneath this. Everybody was shocked. SAC Ahmedabad called me. PRL Ahmedabad called me. Why I could say this? Because during our survey of the water quality from Siachen to desert, the DRDO is responsible. We found that in the deep groundwater, bromine is present, iodine is present, nitrate is present, fluorine is present. This all chemical picture speaks of a marine flora, not of the ground flora, groundwater. Then I sent this water to BRC. BRC told it is 16,000-year-old water. Vedas written 5,000 years only. This our Sanskrit of English and all engineering is 400 years. 16,000-year-old water. That time it was well-wooded, marshy land, and you know Gothal was the biggest airport of the country in the Gujarat region. Now, as my friends told, many places in the process we got the sweet water. I am also a member of the Haryana Sewerage Saraswati Heritage Board, and I presented a keynote address in Chandigarh also, and ISRO has done a wonderful job. Saraswati has been unearthed, a number of places we are finding sweet water. When we extrapolated these points in the desert, we could find the many channels. It is not Pachpadra, it is Panchabhadra. 5 rivers, tributaries, distributaries used to meet what we called ocean, the 3rd, 4th century temples. All, as my friend told, our Saraswati Upanishads were. Last few words. So friends, the Ganga originates from Gangotri with the small spinnerets, choti choti. Then it makes the Ganges here. I find here, see, we have 6 universities in Jodhpur, IIT, DRDO, AFRI, Kazari, DST, all these are the small droplets. If these droplets join, we can make a mighty Ganges. We can solve all the problems of the country, not here, Patalva. I request all the 3 directors here, kindly, this is some proposal which I give, how to unearth Saraswati help it. Thank you very much for calling the old man, the old scientist, not the old monk. Thank you.
Thank you, sir, for sharing your wisdom with us. Next, I would like to take this opportunity to invite our chief guest, Professor Sandhu Chaudhary, sir, to share his knowledge and wisdom with us. Please, sir.
Respected Dr. Ram Gopal, my colleague and friend Sri Ravindra Kumar, Professor Ajay Sharma, and all dignitaries who are present here, as well as the faculty colleagues and the students who have been part of this international conference. I think the whole initiative to organize an international conference on desalination and water treatment and its recent trend is very topical and timely. We know that globally, humanity is facing crisis with reference to water. And clean drinking water is a challenge not only for the region of Jodhpur and around, but it's a global problem. And availability of water is not just clean drinking water. Even when the water is available in this region, the contamination of the water, and particularly fluorides, as well as other chemicals, actually make drinking that water a health hazard. So therefore, getting clean drinking water is a challenge, and particularly also if you see in variety of scenarios, we don't even bother to talk about, but also heavy metals are also as contaminant is present in the water. So there is a necessity to develop technology for clean drinking water. I think I'm just making what I'm talking about is I'm just generalizing the topic of this conference to that of searching for clean drinking water. And in fact, the young friends who are here, and they will face a future world where water will be as critical as that of oil today. We are actually seeing, because of the Ukraine war, our oil prices are just soaring, and we do not know what will be even the condition of economy with the oil. But I think in next 25-30 years time, it will be water. And water is possibly the biggest challenge to humanity today. Now, if we look into that, it is absolutely essential. There has to be collaborative, multi-institutional, big team effort to address this problem. In fact, what Mr. Ravindra Kumar was referring to, Jodhpur City Knowledge and Innovation Cluster or Innovation Foundation, that was a project that is a project, ongoing project, supported by the Office of Principal Scientific Advisor to the Government of India, where one of the key topic that we are addressing is a water sustainability. In fact, management of, even if you look at Jodhpur, management of wastewater is absolutely critical. Even Jodhpur has one of the highest water table. Height of the water table is one of the highest in the country. But that water, the degree of pollution of that water is much higher than a standard groundwater source. And that also in many cases because the local industry has actually led to to lead to their discharge going into underground rather than properly getting treated. And why they are not getting treated is also an economic challenge, because the things are absolutely interlinked. If they have to give a product which is competitive in the market, then if they invest into their wastewater treatment, the cost of the product changes, the cost profile changes. So from that perspective also, it's very important as an engineering research problem to come up with the technologies which are low cost but also enables treatment of wastewater. If we move our attention from that of industrial wastewater and treatment of industrial wastewater, look into your personal consumption of water. I think, see, every time we take a bath, it's about 4 to 6 liters of water with what we use. And that water is not absolutely dark water. Dark water means which is not anyway humanly usable, but that can be used. It's not like that. That water is good enough for flushing and other purposes. But actually, if you look into the water cycle and water distribution system, the entire distribution system design is today towards providing almost drinking quality water for every purpose. In fact, we really do not have differential supply. Once upon a time in cities, in fact, I know of my childhood in Calcutta, there was one supply where used to come directly from the Ganges, and another which is treated water coming from Tala. But that differential supply has gone today. And in fact, all treated waters are being used even for bath, flushing purposes, as well as for drinking purposes. Even although we may put a filter or etc., but in the process we are wasting a huge amount of water, which could be recycled and reused. And therefore water also, if you see the requirements of water, there is a gradation in the requirements of water. And since there is a gradation in the requirement of water, starting about absolutely clean drinking water to variety of various shades of grey water to actually dark water which is completely unusable, there are various ranges. And I think philosophically, and in fact it is happening globally also, that designing of water supply system which caters to different quality of water for different purposes. And that has been calculated that can actually save almost 30% of water usage, particularly in the urban scenarios. And in fact, the other things, the campaign we have already seen that while you're brushing teeth, you're keeping your basin tap open and you're wasting water. Now why I'm trying to come to this is these are not nothing to do with desalination, but this is absolutely critical in terms of the water conservation. It's absolutely critical in terms of what we are talking about today, sustainability of the drinking water. When we are talking about actually following up the track of Saraswati and doing satellite imaging, doing ground penetrating radar imaging, all kinds of technologies to identify source of water, at the same time, we should also pay attention towards development of technologies so that we can minimize the wastage of water and we can do recovery of water from the wastewater. The water recovery is something absolutely critical in terms of technology and which is majorly a chemical engineering problem. And in terms of actions, what we was talking about Jodhpur City Knowledge and Innovation Cluster, see, one point is what we are working on is trying to provide clean drinking water, particularly to the schools in and around the city of Jodhpur. And there we have used a model of providing the filters, which the filtering process doesn't require energy. These filters, in fact, ultra filters, and they can be opened up by the school kids. We have used the technology of the filters and we are deploying it, which can be completely managed by the school teachers and the school kids. They can clean and put it back, and it also doesn't have an energy requirement. Therefore, what is important is that local sustainability of provisioning of the clean water. If I put an RO over there or any such system, that what PHED Rajasthan has done, actually maintenance of this system and servicing those things as a problem. If you look at the data, you will find they have been installed, but if you go back to them after 5 years, between 3 to 5 years, most of them have become unusable. So therefore, technology should be also people's technology. This is something very, very important. When we talk about engineering, we talk about sophisticated technology and technologies which can be done in the sophisticated labs. But we should be also in a position to transform the technology to a level where the common man can have a participation into the technology. And that's a people's technology. If we talk in terms of people's technology, it's absolutely critical for water, because water is used by each and everyone, and he or she should have developed connectedness with the technology that we're using. The other scheme that we are talking about, therefore as part of these, we are also working on smart water grid, where we actually differentiating the different supply of water. We're also working on the problem of CTP, which is actually processing these textile, the industrial wastewater in Jodhpur. And this is a project we're trying to develop with Fraunhofer and working together to solve that problem. The other important thing I would want to tell the community over here is that IIT Jodhpur has instituted a chair professor position in the area of sustainability of drinking water, supported by the Ministry of Jal Shakti. And that professor position is not just pure research, is actually to build a community. In fact, it has the component for research, component for involving faculty and students of different institutions together to work on sustainability of water resources. If there are drinking water resources, even if you see that Indira Gandhi canal, that there are questions in terms of sustainability, because the quality of water is a suspect. How much of that evaluations we have done, we do not know. But if we see the secondary data shows the prevalence of certain cancer types, which might be because of pesticides and heavy metal contamination of the Indira Gandhi canal water. Now, these are the things we need to look at very carefully. So sustainability of the drinking water is a movement which our community has to take part. Community has to identify where are the resources there, and to make them really sustained, preserved, and not to be destroyed. The huge problem happens is that even there are low-lying wetlands. In fact, actually see, Jodhpur is known for number of talaus all around. Now, maintenance of those talaus is a challenge. And those can also be source of good drinking water. And if we can take up as a community movement, the conservation and preservation of those water bodies, that can actually add to the ecosystem as well. And we are part of the bigger group, which is Jodhpur City Knowledge and Innovation Foundation, where even Defense Lab Jodhpur is part of it. In fact, we are signing MOU with MBM College. In fact, our CEO, Dr. Toteja, is also here. We shall be signing an MOU, and we shall be all part of these activities, including the initiative which has Jal Shakti Ministry has started through constituting the chair professor position at IIT Jodhpur. And I'm very happy to report that such professor position has been created only 6 places across the country, and one of them is IIT Jodhpur. And this is not only for IIT Jodhpur, this is for Jodhpur. And my submission to the community here, let's join hands, let's work together to address the most critical problem of current generation, that of clean drinking water. Thank you.
Thank you, sir, for this insightful address. Next, I would like to invite our Honorable Vice Chancellor, Ajay Kumar Sharma, sir, to inspire us with a kind address. Please, sir.
गुड आफ्टरनून एवरीबॉडी। आज के हमारे कार्यक्रम के मुख्य अतिथि प्रोफेसर शांतनु चौधरी जी, डायरेक्टर आईआईटी जोधपुर। आज के हमारे स्पेशल गेस्ट श्री रविंद्र कुमार जी, डायरेक्टर डिफेंस लैब। मोस्ट रेस्पेक्टेड हमारे बीच में आज उपस्थित डॉक्टर राम गोपाल जी, एक्स डायरेक्टर डिफेंस लैब एंड प्रेजेंटली चेयरमैन के रूप में भी सर काम कर रहे हैं। मेरे वरिष्ठ साथी, मतलब मैं कहूँगा ब्लेंड ऑफ यंग एंड मोर यंग एमबीएम फ्रेंड्स, जिसमें मोर यंग वाला सेक्शन ये है और यंग वाला सेक्शन इधर सामने बैठा है। एसके सिंह जी, वर्मा जी, सांखला साहब, अनिल व्यास जी और हमारी टीम यंगस्टर्स एंड बाहर से पधारे हुए अतिथिगण एंड ऑल पार्टिसिपेंट्स एंड स्टूडेंट्स। सबसे पहले तो मैं जो है सरस्वत साहब का नाम मैं इसलिए छोड़ा था कि इनको बाद में लूँगा मैं। सरस्वत साहब को बहुत बहुत, इनकी टीम को बहुत बहुत बधाई देता हूँ इस सक्सेसफुल इंटरनेशनल कॉन्फ्रेंस जो कि एमबीएम यूनिवर्सिटी की पहली है, विद द होप दैट मैनी मोर सच कॉन्फ्रेंसेज विल कम इन फ्यूचर। एक स्पेशलिटी इस कॉन्फ्रेंस की जो ये होती है, यूजली आप और हमने सबने भी बहुत कॉन्फ्रेंसेज अटेंड करी है, ऑर्गेनाइज भी करी हैं। कॉन्फ्रेंसेस के एंड में कुछ रिकमेंडेशंस आती हैं, वो उसमें से गवर्नमेंट को और जहाँ वो सब जगह सर्कुलेशन में जाती हैं, और उसमें से कितनी एग्जीक्यूट होती हैं उसको मैं डिस्क्राइब नहीं करूँगा बिकॉज इट इज़ नोन टू एवरीबडी। द स्पेशलिटी ऑफ दिस कॉन्फ्रेंस इज, किसी मतलब मेरे को ध्यान नहीं आता कि इनॉग्रल फंक्शन में उस कॉन्फ्रेंस की एक रिकमेंडेशन आ जाए, दैट टू फ्रॉम द ऐसी अथॉरिटी जो कि उसको एग्जीक्यूट करा सके। दिस इज़ रियली वन ऑफ द ग्रेट थिंग्स। और उसके साथ एडिशन ये है कि वैलिडिटी में वो एग्जीक्यूशन शुरू हो जाए। जैसे मैंने भी कहा और सर ने भी कहा, वी मेक अ टीम एंड वी होप दैट बाय द एंड ऑफ अप्रैल, थोड़ा सा अभी सर के वहाँ थोड़ा बिजी हैं इस वजह से, अदरवाइज एट द अर्लीस्ट बाय टारगेट इज़ बाय द एंड ऑफ द अप्रैल ये एग्जीक्यूशन मोड में आ जाएगी पूरी। सो दिस इज़ द ग्रैंड सक्सेस ऑफ दिस इंटरनेशनल कॉन्फ्रेंस। इसलिए मैंने कहा फ्यूचर में ऐसी कॉन्फ्रेंसेस की ज़रूरत है। कॉन्फ्रेंसेस की ज़रूरत तो है, पर ऐसी कॉन्फ्रेंसेस की खास ज़रूरत है। तो ऐसा टॉपिक लेने के लिए और उसको इस ढंग से ऑर्गेनाइज, सर एंड इस टीम जो यहाँ हैं, दे आर रियली, दे हैव डन अ वेरी गुड जॉब। एंड फ्यूचर में भी हम सारी जो हमारी एमबीएमटी की खास तौर पर मैं इस ब्लॉक को ज़्यादा कहूँगा कि दे शुड कम फॉरवर्ड एंड टेक सपोर्ट फ्रॉम सीनियर्स एंड कम फॉरवर्ड टू ऑर्गेनाइज सच गुड कॉन्फ्रेंसेस। इसके साथ जो है वी आर फॉर्चुनेट टू हैव सब डिग्निटरीज ऑन द डायस। हमारे साथ आईआईटी जोधपुर भी है, सर आए हैं, चौधरी साहब, और डिफेंस लैब है आईआईटी जोधपुर का। जैसे सर ने कहा, डेफिनेटली वी विल बी ज्वाइनिंग हैंड्स वेरी सून, और एक बहुत अच्छे फ्रूटफुल उसमें हम लोग आगे बढ़ेंगे। और जो हमारे आईआईटी जोधपुर का जो इंफ्रास्ट्रक्चर है और दूसरी फैसिलिटीज़ है, एंड दे विल बी ऑल्सो यूजिंग आवर फैसिलिटीज़ एंड मे बी वी कैन से इंटेलेक्चुअल माइंड्स ऑफ एमबीएम, क्योंकि सर वाकिफ़ हैं कि एमबीएम का क्या स्टेटस है, एंड देयर इज़ लॉट ऑफ थिंग्स टू गेट फ्रॉम एमबीएम ऑल्सो। और जैसा कि अभी हमने डिफेंस लैब से ऑलरेडी वी हैव जॉइंड हैंड्स, एंड आई वाज नॉट एक्सपेक्टिंग ए वेरी सून वी विल बी कमिंग ऑन सच यूजफुल प्रोजेक्ट। सो दिस शोज़ दैट जब दिल में अच्छी चीज़ है तो अच्छे काम अच्छे होते हैं, ईश्वर भी मदद करता है। सो द एमबीएम, पता नहीं वो किस मुहूर्त में सर के साथ हम डिफेंस लैब में बैठे थे, एंड सर को भी उम्मीद नहीं होगी कि इतना जल्दी कोई इतना बड़ा अच्छा प्रोजेक्ट आएगा। एंड दिस विल बी अ बून टू यू कैन से कंट्री, एंड बहुत अच्छा जाता है तो दिस विल गिव अ नेम टू जोधपुर एट इंटरनेशनल लेवल। पर जहाँ तक हम क्या बात करते हैं पानी निकालने की, तो मैं जो टीम इसमें काम करेगी, आई वुड जस्ट रिक्वेस्ट देम दे शुड पे मोर अटेंशन हाउ टू रिटेन वाटर। कंजर्वेशन ऑफ वाटर उतना ही इम्पॉर्टेंट है, तो दे शुड टेक केयर ऑफ दैट, नॉट ओनली एक्सट्रैक्टिंग द वाटर, और पानी निकालने का ही नहीं सोचे, क्योंकि जितना पानी हम निकाल रहे हैं उससे ज़्यादा हमको वापस अंदर उसमें जाना चाहिए, ताकि वो इट विल बी used by our generations to come. जैसे हम जब ले रहे हैं सरस्वती की बात कर रहे हैं, उस ज़माने की आज से कितने साल हैं, 500 700 1000 साल पता नहीं, और से भी पुरानी बात है। तो जब हम उस लेवल पे जा रहे हैं तो हम ये उम्मीद करें कि हम 7000 साल बाद भी ऐसा कुछ सिस्टम बनाया जाए तो हमारी उस वक्त की जो जनरेशन है वो उसको यूज़ में ले सके। और जैसा कि मैं हमेशा कहता हूँ और सोचता भी हूँ कि एक विज़न बड़ा होना चाहिए, एक सोच बड़ी होनी चाहिए, देन ओनली वी कैन एग्जीक्यूट ऑन। तो सर का जो अपने हमारे नायक साहब राम गोपाल जी का विज़न है सुजलम, मैं अभी सर का वो रिपोर्ट बता रहे थे सर, तो इट वाज अप टू 2001 या 2002। तो वो जो सपना देखा था सुजलम का, वो आज 2022, अब जितना समय जो लगेगा, मतलब रिसेंटली 2025 भी हम पकड़े या 2024 भी हम पकड़े, अब साकार होने की उसमें है। तो सोच हमेशा बड़ी रखनी चाहिए, देखना लंबी दूरी से चाहिए, डेफिनेटली वो काम आती है। और तो मैं अब तो हमारी सोच तो खैर इतनी नहीं जाएगी, लेकिन द टीम व्हाट यंगस्टर्स स्पेशली दोज हु आर सिटिंग एट द बैक, आई वुड जस्ट रिक्वेस्ट देम दैट दे शुड थिंक वेरी हाई, बहुत ऊपर तक सोचें और उसको अचीव करने की कोशिश करें। डेफिनेटली जीवन में कोई चीज़ ऐसी नहीं है जो नहीं की जा सकती हो। सो यू कम फॉरवर्ड विद अ लॉन्ग थॉट एंड वेरी स्ट्रॉन्ग डिटर्मिनेशन, दैट इज़ व्हाट रिप्रेजेंटेशन ऑफ MBM एंड दैट व्हाट MBM टीचर्स अस। MBM की भी शुरुआत ऐसे ही है, यू हैव अ स्ट्रॉन्ग डिटर्मिनेशन, स्ट्रॉन्ग थॉट, हार्ड वर्किंग, गो फॉर एग्जीक्यूशन, तो हम उसमें लाएंगे और डेफिनेटली विल वर्क इन द। और एक चीज़ और जो सर ने अभी अच्छी बात की कि वी आर नॉट, इट इज़ चेयर इज़ नॉट फॉर IIT जोधपुर बट इट इज़ फॉर जोधपुर। सो मेरी भी सोच यही है कि इट इज़ एवरीथिंग इज़ फॉर जोधपुर नॉट फॉर IIM। सर का भी हमारे रविंद्र जी ने भी ये कही बात कि इट इज़ फॉर जोधपुर। तो जब 3 ऑर्गेनाइजेशंस जो कि जोधपुर की अहम ऑर्गेनाइजेशन हाथ में मिलती है, एंड द थिंक ऑफ द जोधपुर मीन्स इट्स द टीम जोधपुर, वी कैन से नॉट टीम MBM, देन नॉट टीम IIT, नॉट टीम डिफेंस लैब, we can combine, it's a team Jodhpur, and definitely in future team Jodhpur will bring a name to Jodhpur in all good faiths. So once again I congratulate organizing secretary and the team for a successful with a very good outcome based international conference, and सर को मैं इसमें वापस हमारे जो डिग्निटीज़ हैं इनका मैं वो शुरुआत में भूल गया सर, आई वुड लाइक टू वेलकम इन दिस MBM कैंपस and hope that we will be calling you again and again for organizing such things, and we will have some good interactions and contributions to each other. Thank you so much.
Moving ahead with the procession, I request Dr. Kailash Chaudhary to please come on stage and present the certificate of participations before our guest. And I request our chief guest, Professor Shantanu Chaudhary ji, and our presiding guest, Professor Ajay Kumar Sharma ji, to please provide the certificates of presentation to all the presenters. Please, sir.
Thank you, Abhishek. We are offering certificate for the paper presented offline only, and for the papers presented online, we'll send certificate later. So these are the papers presented offline, and mostly our authors are from Jodhpur. First, I will invite Mr. Dhirendra Rajpurohit, an authored paper with Professor Suresh Kumar Singh. Please come on the stage. वो वहाँ पड़े लेके ना। Next, I would like to invite Rajesh Kumar, Santosh Kumar, Dipesh Patridar ji, Prashant Vasishthan, authored by Ravindra Kumar sir also. I would like to invite team DRDO. Please come on the stage. यहाँ पे क्या पढ़ना है? Next, I invite Mr. Shyamlal Chaudhary along with author Professor Suresh Kumar Singh. Please come on the stage. Next, I invite next paper presenter Lalita Solanki ji along with Professor Ravi Saxena ji. Next, I invite paper authored by authors R.C. Meena, Mansi Gupta, Anjali Palaria and Lal Chand Yadav. Please come on the stage. Next, I invite authors Pooja Sharma, Vikas Chandra Janu, Ramkrishnan Meena ji, Parmeshwari Malodia and Dipesh Patidar ji, team DRDO. लास्ट में अनाउंस करूँगा या पहले लास्ट में बेस्ट पेपर है ना फिर यहाँ से बुलाना क्या दोगे यहाँ बुला सिर्फ अनाउंस करना है बुलाना भी ठीक नेक्स्ट आई इनवाइट राकेश कुमार आर्या एंड जयश्री राठौड़ प्लीज कम ऑन द स्टेज Next, I invite Mr. Yogendra Chauhan, co-authored by Professor Pradeep Kumar Tiwari from IIT Jodhpur. And I'm happy to announce that Mr. Yogendra has received Best Paper Award also for this conference. He has presented a very well paper and jury has selected his paper as the best paper for this conference. Please give him a big round of applause. The best paper presented by Mr. Yogendra Chauhan from IIT Jodhpur. Next, I invite authors Daulat Singh Shekhawat ji, Vikas Chandra Janu ji, Pratibha Singh and Kuldeep Singh ji. Please, sir. Next, I invite Mr. Rajesh Kumar ji, Amita K. Patil ji, Sunita Verma ji, Prakash Karadi ji, D. Patidar, Prashant Vasishta ji, and a paper co-authored by Engineer Ravindra Kumar sir, Director at Defense Lab, Jodhpur. Please give him a big round of applause for team DRDO. I wish to mention here also that the earlier paper presented by DRDO team by Ms. Pooja Sharma is selected as the second best paper of this conference by Pooja Sharma and team DRDO. And in last, I would like to invite Ms. Neetu Pariyar from MBM University, Jodhpur.
Thank you, sir. Thank you. All the guests, I request all the guests to please take the seat. Certificates for the online presenters will be sent later. Moving to the second half of this valedictory function, I would like to request Professor Sushil Saraswat sir, Organizing Secretary of this conference, to present a memento to our chief guest, Professor Shantanu Chaudhary ji. Please, sir.
Now I invite Abhishek God to present memento to our special guest, Sri Ravindra Kumar ji, Director, Defense Lab.
Next, I would like to request Dr. Kailash Chaudhary ji to please welcome and present a memento to Professor Ram Gopal ji, Ex-Director, Defense Laboratory, Jodhpur. Moving ahead, I would like to request Professor Arvind Kumar Verma ji to please come on stage and present a memento to our Vice Chancellor, Professor Ajay Sharma sir. Moving ahead, I'd like to request Mr. Pradeep Kumar sir, Assistant Professor, Mechanical Engineering Department, to present a memento to our Dean, Professor Sunil Sharma sir. Moving towards the end of this procession, I would like to request Professor Sushil Saraswat sir, Organizing Secretary, InDACON 2022, to please present an event report and vote of thanks.
Thank you so much, Abhishek. A warm welcome and good evening to today's chief guest, Professor Shantanu Chaudhary ji, Director, IIT Jodhpur. Honorable Sri Ram Gopal ji, Ex-Director, DRDO and President InDA, and the great scientist of India who has worked on Sujlam for India. Shri Ravindra Kumarji, outstanding scientist and director, Defense Lab, DRDO. Professor Ajay Sharmaji, Vice Chancellor, MBM University, Jodhpur. Professor Sunil Sharmaji, Dean, MBM University. Respected heads, faculty members, colleagues, media persons, and dear friends, and other attendees. As an Organization Secretary of InDACON 2022, I present you the vote of thanks for the valedictory ceremony of International Conference on Desalination and the Water Treatment, recent technological advancement, challenges and opportunities, and annual Congress of InDA 2022. Today, our 2 days International Conference InDACON has come to an end, and it has been an incredible journey of months who lead us these successful outcomes. I feel elated. Announced that 25 onlines, 10 offlines, and 22 poster technical papers have been presented in the InDACONs. Out of 17 from IITs and NITs, 17 were from research organizations like DRDO and BARC, 17 from industries, 20 from the research scholars, and apart from it, we have 11 numbers of invited talks from the international and national experienced faculty, scientists, and industrialists. To begin with, I would like to express my sincere gratitude to the Honorable Jal Shakti Minister, Shri Gajendra Singh Ji Shekhawat Sahab, for accepting our invitation and gracing the inaugural functions with his presence and blessing, in spite of his busy schedule. His kind speech has surely motivated us. Big thanks to Shekhawat Ji for sharing the work and achievement of Jal Shakti Ministry for our country. I also express my heartfelt gratitude to the chief guest of today's, Professor Shantanu Chaudhary Sahab, Director Jodhpur, for sparing his valuable time and showing his word of wisdom. I would like to thank Professor K.S. Srivastav Ji, Vice Chancellor Jai Narayan University Jodhpur, for providing valuable insight in desalination in this international conference. I give my sincere thanks to Shri Ravindra Kumarji, outstanding scientist and director, Defense Lab, for guiding us and supporting us financially. I give my deepest thanks to Professor S.P. Chaurasia Ji, President InDACON, for providing the opportunity to conduct this international conference at MBM University Jodhpur, and for giving us financial support. I cannot forget to mention that Professor Chaurasia Ji has come especially from Jaipur to Jodhpur to attend this conference. I am short of words while thanking Professor Ajay Sharma Sir, Vice Chancellor MBM University, for his continuous guidance and encouragement since the day one that we have shared this news that we are going to organize this international conference. Sir, you help us even in the late hours that I know I disturb you, and I'm very thankful for this. And the financial support given by the TechCube Third for this conference is highly appreciable. I express my warmest gratitude to Professor Sunil Sharma Ji, Dean Faculty of MBM University, for showing confidence in us and advising us, which we have helped towards the successful conference organization of InDACON. On behalf of organizing committee, I would convey my heartfelt gratitude to all the participants and delegates. Without their participation and support, this conference would not have been possible. I render huge appreciations to our keynote speakers from India and abroad, especially Professor Sanjay Tiwari Ji from USA, Dr. Muslim Dimar from Turkey, Professor K.K. Pant from IIT Delhi, Professor Vimal Srivastav from IIT Roorkee, and Professor Tamal Banerjee from IIT Guwahati, who has taken his time and were available in spite of having different time zone. We have been fortunate to have some of the eminent professors from academia, industries, and research and development in the area of water desalination and wastewater treatment. I am grateful to Professor V.K. Srivastav Ji, Honorable Treasurer InDA, for his precious support, and also congratulate him for receiving the Lifetime Achievement Awards. Thank you, Professor Srivastav Ji, for coming all the way from Bombay to Jodhpur. I sincerely thank the member of Advisory Committee, Professor Arvind Verma Ji, Professor R.P. Chaudhary, Dr. Kailash Chaudhary, Abhishek ji, Imarti Kumari ji for valuable suggestions and time. I take this opportunity to thank Professor S.K. Singh and Dr. Surendra Punia as offline keynote speaker and viewing all the technical committee for providing his valuable comment in time and helping towards the improvement of quality of the paper presented in this conference. It has been our pleasure to host all the participants and the conference of InDACON 2022 at MBM University Jodhpur. I must say that the participants were very enthusiastic and it was their zeal which indeed took this international conference to another level. I acknowledge the unwavering support received from head of the department, the faculty members, and staff of MBM University. I also want to thank Dr. Anil Vyas, Mr. Ketan Jangi, Dr. Gautam Lalwani, Dr. Sangeeta Purohit, Mr. Rajesh Dadich, and all my non-technical staff of the Chemical Engineering Department who gave their precious time organizing this event and working day and night for the same. I am also thankful to the Defense Research Lab, DRDO Jodhpur, scientist Mr. Deepesh Ji Patidar, Dr. D.K. Tripathi Ji, Dr. Vikas, Dr. Rajesh, and Dr. Manish, and all other scientists and scholars for helping us in all possible ways. I appreciate the effort of all the research scholars and all chemical engineering department students of BE third year, second, third year, and final year who had worked greatly help to organize this international conference. I also want to thank Mr. Pradeep and Amit ji for helping, and I do not want to forget my favorite students, Mr. Mahesh Jaks, who has worked for website to make this international conference worldwide, give this worldwide publicity. I once again thank you all for the contribution without which I would not have been succeeded. I'm very thankful to the media persons and the whole coverage of this event. I'm sure that each and everyone who have helped us and have been benefited by attending this conference, and I'm sure that our conference will continue to get generous support from various organizations in future also. We hopeful to organize more such conference in future and receiving great response from all of you. Thank you so much, sir.
Thank you, sir. Thank you for sharing your thoughts with us. To conclude this two-day international conference, I would like to invite a team of students, and I request all the audience and guest members to please stand up for a national anthem.
जन गण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड़ उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्छल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाए तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे.
Thank you, students. So I would request all the guests to please proceed to your seats.